Hey everyone, welcome back. Today we are building something special, an end-to-end machine learning pipeline using Astro. And our use case will be a real-world sales forecasting pipeline based on Astro CLI. But before we get hands-on, this video is sponsored by Astronomer, the company behind Apache Airflow. Airflow is the world's most widely used open source tool for orchestrating data pipelines with over 324 million annual downloads, more than 3,400 contributors, 41k GitHub stars, and a thriving community of 60,000 members on Slack. Astronomer isn't just maintaining Airflow, they are driving its future, contributing thousands of improvements and making it easier than ever to run in production with their modern managed platform called Astro. With Astro, you get all the power of Apache Airflow without having to manage the infrastructure or upgrades yourself. So in this video, we'll take a practical use case, which is going to be sales forecasting. And I'll show you step by step how to, number one, ingest data from multiple sources. 2, transform it and make it ready for machine learning model training. 3, you train, validate, and forecast this using these models that you've just trained. Then we deploy this model so that it's always ready for productions and predictions. Then we schedule and orchestrate everything with Astro. By the end of this video, you'll see how easy it is to go from raw data to actionable forecast, all inside a reproducible, automated machine learning pipeline. Alright, let's fire up Astro and start building this pipeline from scratch. Big thanks to Astronomer for sponsoring this build. Let's get into it by starting with the architecture of the system, and then we go through the end-to-end process of developing this automated pipeline end-to-end. Now, let's take a closer look at what the high-level architecture looks like. I'm still going to break this down to make a little bit more sense as we go along, but yeah, to look at the high-level view and break things down as to what exactly we're going to be doing in this video, this is what the high-level system looks like. We're going to start with creating some sales data, promotions data, and a traffic data, which is kind of standard if you're looking at sales forecasting. Of course, you need the actual sales and some things that will be affecting the sales. Yeah, so we'll be looking at all of this information in greater details, and I'm going to take you through exactly what we're going to be implementing down the line. But once this sales data information is established and we have something similar that we can work with, we can now establish our Apache Airflow that is going to be running on our Docker. So essentially, I'm going to be using Astro CLI. It's one of the best platforms out there, like I mentioned, and it's kind of straightforward to spin up and as many versions of Apache Airflow as possible. If you've been following these videos on my channels and some of my other channels as well, you will notice that you usually want to create a Docker compose and then spin up an Apache Airflow with some of this information. With Astro CLI, it's just a simple command that you run and everything starts running, and I'll show you how to easily spin that up and make that work easily. So essentially, we're going to have 4 different things, maybe 5, that is going to be spinning up by Astro CLI by default. So we're going to start with Apache Airflow, which is essentially what we're trying to build. We're going to have the API server which is used to communicate across all the different containers. We have a triggerer, we are going to have a processor, and also a scheduler. In this case, everything is going to be running on Postgres, of course, as a DB. That's where everything is going to be stored. Then we're going to extend that functionality because we are riding on Astro. We want to extend the functionality to something like MLflow. So as we train our model with Astro, once we finish training the model, then we register it in MLflow, look at the metrics and all the statistics that is required on MLflow, and then we can deploy and promote it to production. That is one. Number 2, all the artifacts and everything that will be used across board will be saved into MinIO, which is S3. So essentially, well, not S3 per se, it's like a drop-in replacement for S3, AWS S3 bucket. So if you are using MinIO, all the API functionalities can easily interface. If you're using something like, if you're used to something like Boto 3, you probably would understand what I'm trying to say. But essentially, all the APIs that are supported in MinIO are essentially on AWS S3 as well. Yeah, so you can either use that or S3, whichever way works for you. And then at the end of the day, we're going to build a real-time streaming UI that you can use to make inference, which is something like Streamlit. You can also use something like a Flask on Python, and if you're using Java, you can spin up some Spring Boot applications or microservices that you can use to infer, or you can even export the models and use it in whatever applications that you want to use it. Yeah, I hope that makes sense. Now let's break it down a little bit more to see what each component entails and how we're going to go down the line to get to our actual implementations. Now, this is our sales forecasting MLOps architecture. We're going to start again the data sources, which is the sales, promotions, and traffic, and then we're going to use Astronomer to spin up these services. Of course, Apache Airflow, the dark scheduling, and some of these auto scaling features, which comes by default as an additional benefit by using Astronomer. Then we use that to create an ML pipeline, which is the extraction, the validating, the engineering, the training, and the evaluation of the models that we're going to do. And I think one box is required in this case, which is the promotion to production. Yeah, I didn't add that, but it's something we're going to be doing as well. Then once that is done, once we have a better model, we're going to promote that into MLflow. So for tracking, registry, and artifact registrations, we'll see everything inside of MLflow, and a copy of all of that information will be in MinIO S3. And why S3 MinIO, you ask? It's probably because you want to have a model storage, yeah, and you want to be able to extract this information from there to use it in other services. You can also connect to MLflow. So if you prefer not to use MinIO component in this case, it's actually optional, but majorly MLflow, you can from there get your artifacts directly from the run ID and all the information. Now, some of the models that we're going to be creating, which is the arrow that points down, which is this guy, we are going to be using XGBoost model, where we prioritize some features, of course, which is going to be required in the sales forecasting pipeline. Then we have the light GBM, the light gradient boost model, and then we have the prophet and the ensemble model, which is going to consolidate these two models that are doing the same thing, and leveraging their strong points, yeah, if I can say that. So the strengths will be leveraged across board, and you see how we do that as we go along. Now the visualization layer is going to be something like performance metrics, predictions versus actual. We have the residual analysis and feature importance. All these things will be there, and then we are loading straight from MLflow, not MinIO in this case, from MLflow. We'll be loading straight into Streamlit to do real-time inference and predictions. And as data comes through, we can easily infer on a daily basis, on a weekly basis, on a monthly basis, however you want it, or even you can predict the future as to 30 days, 60 days, 90 days to see what kind of sales you're expecting across board, on average, the maximum, the minimum, and stuff like that. That will make more sense as we go along as well. So those things will be implemented in real practice. Now, that is all about the system architecture overview, which is our MLOps architecture. Now, going down through the data flow that we'll be going through across board, some of these will have to come later, but I just want to show you what exactly the data flow will look like. So we have the raw data set generation. I don't have a company that I can use for this particular project, so we'll be generating a realistic data that is going to be simulating. I try to, as much as possible, use a sample business out there that has some data online. So we're going to be simulating something similar to that, and we have some data validation I'll be doing before we validate or create the model. So we do some feature engineering where we extract the time features, the lags, the aggregations, and stuff like that. That will make more sense, don't worry. If this is your first time creating a model, don't worry, you're going to be an expert at the end of this video. Then we use the feature engineering that we've just done to create a model. Yep, not a single model. We create two, XGBoost and light GBM, like I mentioned. The prophet you can use as an alternative to ensemble model, or you can create a separate model with prophet. That is left to you. But I'm going to be showing you how to create the XGBoost model, the light GBM, and we're going to use ensemble model to see the contributions of each of this model, especially when we want to use ensemble to infer what we're going to be using in production. That will make more sense if that doesn't make sense right now. But if it does, congratulations, you're good to go. Then we have the model evaluation where we see the metrics, the visualizations, and some diagnostics information about these models. What's the performance of this model? the accuracy, the RMSE, the MAPE rather, and the R square model. Yeah, you see what that means shortly. Then we have the artifact storage, where we store in MLflow and MinIO. Again, MLflow and MinIO, well, MinIO may be optional, but MLflow is kind of critical in this case. So we're going to prioritize MLflow, and MinIO will come as an optional functionalities in case you don't need it. Now, how do we deploy this? We're going to start with the Astronomer services. Redis is optional in this case. We're not going to be using Redis, because Redis, if you're using Celery, then you probably need Redis. But if you're not using Redis, if you're not using Celery executor, you're not going to be needing this. So for now, we're not needing Redis. So we're going to be having the web server, the scheduler, the Postgres SQL as the DB, and all the information that I showed you earlier in the high-level architecture. Then for our ML services, we have MLflow and MinIO. Then we load the data straight into Streamlit UI and Infer. Just below that, we have the Docker volumes that are going to be created. So if you don't have enough space in your system, you wouldn't have to struggle, don't worry, but you might have to just limit the number of data sets that you're using. So in my case, I'll be using data from 2021 to 2025, which is as at today, 9th of August. But in some cases, you may not have that bandwidth. You will have, but when you're training your model, it might slow down your system. So in some case, you might have to limit it to a year worth of data, or 2 years, or 1 year, 6 months, whatever it is, however month you want to use. So you can, I will leave that to you to decide. I will show you how easily configurable that will be. Now, again, the ML pipeline detail flow. I know this is a lot of architectures and all that, but I'm just trying to break it down to make sure that we are all on the same page at the end of the day, so we can easily communicate effectively as we go along, because I might be referring to some of these things in the while we are coding. So these are the kind of things that are going to be like a prerequisite for us to understand. So we start with the ingestion, which are going to be Parquet file. Think of a business that you're going to be, at the end of the day, you do like a balance sheet end of day process, yeah, where you generate what your sales are, your income, the expenditures and stuff like that, and each of the sales that you make on a single day will be consolidated into a single Parquet file. Now think of that over a year, over 2 years, 3, 4 years, and the rest like that. We can use that to essentially infer on the model. And also we have the data quality validation checks that will be done, feature engineering, something like the time, the lag, the rolling encoding and stuff like that. You will see that in play as we go along. Then for training the model, validating and testing, we did 70, 15, 15. Some other people will use 80, 20, maybe not validating, just training and testing. But in our case, we did training, testing and validating, but 70, 15, 15 in that proportion. So we are going to be doing 3 models, 2 models. We can either use ensemble model or Prophet. We're not going to be training Prophet eventually, but you can do that as well. I'll leave that placeholder in case you just want to plug in Prophet in this case for time series analysis, seasonalities and holidays. We handle some of this in the model. But essentially, for SG Boost, we have gradient boosting, where we prioritize some features that are important to us. Then we have the tree-based architecture, the optional HPO, excuse me, optional hyperparameter optimization. This will be in place as well. Then the same thing for the light GBM, we have the histogram GB, we have histogram gradient boosting, in case you don't know what that GB means. We have fast training, then the optional hyperparameter optimization as well. Then for Prophet, so assemble model is the weighted average, yeah. When you think of like a house, yeah, how many contributions do you have? You have 2 people contributing to let's say 1,000 quid, yeah. In this case, some people will say 600 pound, 400 pound, 50 50, 40 60, you know, that proportion, yeah, just to make a whole number 1. How many did you contribute into making this 1? That's essentially what we're trying to say when we say ensemble model. Then we write the data into model artifact into MLflow and MinIO storage. And then for the Streamlit architecture, it's kind of straightforward. You can either have a file upload, a manual entry, or the sample data, whichever one you prefer. But we're going to be doing the file upload. All the placeholders for this manual entry and sample data will also be implemented, so don't worry about that. The same thing here. We have the model management. We load it from MLflow. We cache the model. Of course, we select the type that you want to use for inference, with that ensemble or like GBM or XGBoost, whichever one you prefer. And you do the prediction engine, then the visualization is going to go through as well. Everything is going to be running on MLflow server, and then we're going to export the data, the CSV into CSV, so you can see what the final result look like, the predictions and the confidence bound, which is the lower and upper band, and the average as you go along. You see all of that in a simple demo that I'm going to show you. Okay. I think that is all about the architecture essentially, but now we can go to some of the diagrams, and I'll just quickly run through them to avoid repetitions. Yeah, we have the data generation, of course, the validation, the feature engineering, the model training, of course the storage, essentially breaking down what we've just done in the architecture. But this is very important. If some people look at this component architecture diagram, you see the kind of components that are going to be interacting with each other, and how the relationship will look like as we go along. So when the user triggers a training on MLflow, on Airflow rather, which is the Astronomer Airflow. In this case, I trigger a training. What it does is to go into data generation, which is where the realistic data generation is. Extracts the data cells from there, and of course it returns the data back to Airflow. This data that is returned will be validated by a validator, which we're going to be building, and then from there we have a validation report. Based on this validation report, if it is something that makes sense, we proceed to train the model. Otherwise, we stop the processing. Now, assuming everything goes as we expect, and we go straight into model training, we're going to go into a trainer. So the trainer is where we have all the trainings for all the models, like the GBM, Prophet, XGBoost, Ensemble model, and stuff like that. It's going to be in the trainer section. Now, from the trainer, you can start running, and as you're running, you'll be logging the parameters. Yeah. So we start with GBM, XGBoost, and then Prophet, if you like, and the Ensemble model at the end of the day. So there will be a loop for some of these models that we're training. We keep training them, and as we are training, we'll be logging the metrics and logging the model at the end of the day once we are done training. Then once that is done and the model is generated for all the three models, of course during the loop we'll be generating the charts that compares these three models that have been trained by this system, and that will go straight into the visualizer. We generate the chart in there, and then of course the artifacts from MLflow and MinIO, we synchronize them to ensure that whatever you have in MLflow is you have a copy in our MinIO S3. At the end of the day, we will finish running. So of course we register the best model in MLflow as part of our final training, and then after that we finish the training. Essentially, that is all there is to it. We have a couple of diagrams in here, but as we go along, to make things make more sense, and to visualize what we're trying to do, especially when we're coding, we're going to be showing the rest of these images. All right, that caps it all. I know it's a lot to take in, but yeah, let's get into the actual coding and get started with that. So as I was saying, so imagine you have a store or a business. It could be an e-commerce system, it could be a travel system, or whatever system you have. Most times you're going to be depending on the customers, which is usually the case, of course, when you have a business. So you have a business, so let's call it store A, yeah. And in fact, not a store. I will say let's say Mr. Yusuf e-commerce, Mr. Yusuf e-commerce business. So this is the name of the business, and in this business you have, let's say, different branches across the country. So I have store 1, store 2, 3, 4, 5, 6, 7, 8, and I have up to store 10. Yeah, store 10. So in this case, each of these stores will have the same metrics across the board that I want to rate them on, and it has to be robust enough to be able to go through this entire system. So we're going to have for our sales, so taking one of them, in this case, taking one of them as a case study, let's say store 1, you're going to have for the sales we're going to be taking care of some things to make sure that the sales that is coming in from each of these stores is kind of standardized across board, so we can easily forecast what is sales of a particular store, which one is more profitable, which one will be going down and stuff like that. Now for our sales, we're going to be considering a couple of importance here. So things that can affect our sales, something like renovations. So we have renovations. Yeah, things, if you are renovating a particular store, most times you probably will have to shut it down for a couple of days, or sometimes partial opening where you have some part of the business being shut down and stuff like that. Then you have something like closure, a full closure. Maybe something is happening on that particular day, something is happening in the business and that particular store is not opening, or there's a public holiday that the business is not operating. So you have something like a closure. You also have something like holidays. Yeah, holidays, if it is like maybe things that you're serving, people that you're serving are like on holiday, or people are on summer break or end of the year or New Year Eve or stuff like that. You see the holidays in there, and some particular days of the week. Yeah, days of the week will also be something that we want to consider to ensure that whatever it is, there will be some sales that will be on Monday. Some people will have more sales over the weekend, Friday, Saturday, Sunday, depending on if it is like an e-commerce business. You probably will have more sales coming through Friday evening up until Sunday, well, depending on the kind of business you have. And also we have the weather. So if it is not an online business, you probably have a weather affecting people to come to the store to purchase stuff. And I think we have promotions. So if you have any promotions in place, we can use that. And finally, we have something like seasonality. Yeah, seasonality. In this case, you have something like the Christmas, the gym wears, Easter eggs, and stuff like that. You get the point. So etc. I'll just put the etc. here. Yeah, so those are the kind of things that I think would be something that will be affecting the sales of a particular store in a particular location. There could be some other things that you want to factor in place as well, but some of these things will be what will be factoring in as we go along and implement some of these features, especially in our real-time realistic sales generator that we'll be doing. That is for sales. Now, for some of the features that we'll be considering when we are building our model, so we have some of our features for the models. Yeah, I know my writing is bad, so please bear with me. If you can just follow through as I'm talking about it, we can easily relate with it. So I'm going to change the color to let's say green. Yeah, so we have. Most times, let's start with in light GBM. So in our light GBM, we're going to have something like profit, which is most likely the case, because you want to make sure that whatever profit is being generated in the business is something you want to consider. We have the profit, we have the quantity sold by each of the stores. We have the quantity sold, we have the day of the week, we have the sales. In this case, the sales that are rolling, maybe rolling, let's say in the last 3 days, we can get the standard deviation of that. You can get the minimum of that. You can get the maximum of that, depending on what you are really considering. But we're going to be considering this as part of the features that we'll be using to train our light GBM model. Also, we have the customer traffic. Yeah, the customer traffic. Don't forget, we have 3 sources: sales data, promotions, and traffic. So we'll be using customer traffic to train our model, especially in here. So we have the sales rolling as well. In fact, maybe I can just add this in here as well, because we have the mean in here as a separate entity, but it's not as important as this in the grand scheme of things. So most likely, I'm just going to remove the mean from here. So that it will signify they are not on the same level of importance. Essentially, that's what I'm trying to say. And then we have something like maybe promotions applied. Yeah, I'm just gonna undo that, and we have promotions. Yeah, promotions applied. Yeah, these are the kind of things that you want to use, especially when you're building the model. Yeah, for light GBM, we're going to have something like, let's say this is I don't know, this is hypothetical. Yeah, so let's say this is 30%. Yeah, this is, let's say 10, this is 5, this is maybe 2, this is maybe 1 1 1, something like that. So essentially, when you add everything up, you probably will be close to 100. Especially in times of importance, and not necessarily you don't have to, like, stick to 100%, or these are like percentages. No, this is just like to boost the importance of this particular feature when training this model. So that's for our light GBM. For our XG boost, and I'm going to change the color of that to, let's say, blue. XG boost is going to be similar to that. So we are going to have a prioritization of our sales rolling for 3 days or something. 3 days. In this case, we'll be prioritizing the mean. We'll be prioritizing the mean to as compared to something like standard deviation in the light GBM. We have the profit and quantity sold. So quantity sold as well as the profit. Yeah, and the final thing will be the sales in the last, maybe the median, sales 3 days median, and maybe as promotions or something, promotions applied. Yeah, so these are the kind of things that we'll be considering. We can also get the standard deviation in the last 21 days to add to that. Maybe I can just yeah, maybe sales STD in 21 days. Yeah, so these are the kind of things that you probably would be considering, especially when building this model. So yeah, so for now, we are going to stick to this and make sure that these are our models that we're building respect most of this, and we're going to compare at the end of the day the final results that is generated by the light GBM and XG boost, as well as these features that we're prioritizing and their importance across the business, especially when you're training the model. Yeah, essentially that's all we're going to be doing. Enough theory now. I know it's kind of boring, but let's go into the practical side of things and start the developing the code. To get started, you need to go to astronomer.io/code review. Now, then you scroll down to the bottom, or you just click on get started free. Then it takes you here. Then you can just select the Google. If you're using Google, continue with Google, or you can type in your company email address. In this case, if you type in your company email address, you just click on continue, or you select the Google Workspace email, or with GitHub, whichever one works just fine. So I'll be selecting Google in this case. So once I select continue with Google, it's going to ask me to sign in with my account. Then I can select the account that I want to use to sign in. Okay, then I'll select the account. Once I select the account, then I click on continue. Then for the service agreement, which is usually standard, I'll just select this and then click on continue. Then I get a landing page. I get redirected to the landing page. If you scroll to the bottom, you will see that it asks you to continue to Astro. Welcome to Astro. After that, I'll just select continue. Then in this case, I get redirected to my dashboard, which you can see that I have access to business use case or a personal use case. So in my case, I'll be selecting personal use case, and based on the level of experience, I'll select advanced. And in my case, if you want to join an existing team, a company, or whatever, I'll just select this. I'll select personal learning and development. And in my case, I'll select, I'll change the organization name, Data Mastery Lab. And in my analytics, I'll type in my workspace rather, I'll type in YouTube. All right, and I select that. Okay. Essentially, I get to select either ETL, generative AI, learning Airflow, or even none. If you prefer to have a bootstrap, you can select any of these three. Otherwise, you can just select none to get started. All right. Basically, I'll select my provider that I prefer, and I'll be selecting EU Central. Okay, and then create an account. Alright, so essentially you have access to, if you're using Mac, you can do the setup instructions, or you can follow the details of the setup instructions in as we discuss it much later. Then these are sample codes. You log in and then you deploy. Straight up, you're good to go. If you check your deployment, your account will get created. Then the DAGs, you see the health of the DAGs that is currently running, the statuses, and the rest like that. You can check the rest of the features in here, but essentially you just need to log in. Once you have your DAG in place, you need to log in and then you need to select Astro deploy. Now that you're done creating your account and you have everything set up by yourself on this Astronomer cloud, you can now go ahead to connect your local account to Astronomer cloud, especially if you are using Mac or Windows, or even or Linux, or whatever systems that you're using. You can just follow the instruction in here. If you want to install the CLI and stuff like that, you see it on Mac, for Windows, for Linux. All these steps and instructions is kind of straightforward in here. But if you prefer to get maybe faster, you have the quick start, which comprises the installation and setting it up and all that. But if you just want to do the installation, you can go through this Astronomer CLI installation. But for the quick start, I'm just gonna run this. I already did, so you just copy paste. I'm using a MacBook, by the way, so if you copy this paste it in your terminal, it's gonna use install it for you if you're using Homebrew. So if you don't have an Homebrew, yeah, you probably need to get one. It's kind of easy to manage all the packages from there. Now once that is installed, let's go to the application and get started creating a project. Now to create a project, I'm using PyCharm in this case, and you can see I have a new project being created. So I'll call this sales forecasting. I'll call this Astro sales forecasting pipeline. This is my Astro sales forecasting pipeline. Please, I'm using Python 3.10. So if you're using the latest version, which is maybe 3.13 as at the time of this recording, you probably will have some interface issues or like modules not compiling or whatever it is. But yeah, if you use 3.10, it's kind of stable, and most libraries in the ecosystem kind of supports this. So yes, please ensure that whatever libraries you're going to be using across this project is supported by your Python engine. Please, that's very important, because most people come to me and say the project is not working, whereas once they change the version of their Python or change the library version, everything just works easily. So please be mindful of this Python major and minor versions, not the patch. Major and minor are the ones that you should probably worry so much about. Okay, so I'll create 3.10 and create a new project. So I'm going to be putting this in here. So once this project is created, PyCharm by default usually go through some bootstrapping to ensure everything works fine, and I just trigger the terminal in here to ensure everything works fine. So by default, I don't have to create a virtual environment. That was why I created the Python 3.10. So if you type in which Python, you see the version, the Python location as my Astro in this case. So if you haven't installed Astro CLI, I would recommend you just copy it in here and paste it into your terminal. If you're using Windows, you have to follow the Windows setup process. If you're using Linux, of course, the same thing applies to you. But in my case, I just install the brew, and that installs Astro CLI automatically for me. Kind of straightforward and very fast, so you don't have to worry about it. Yeah, if I clear this up and I say Astro version, I don't need the dash, it's Astro version. I'll just clear this up again, Astro version, and you see there I'm using Astro CLI version 1.35. Don't worry, if you have a latest version, by the time of you are doing the project, you're gonna be just fine. Everything is gonna work just fine. So don't worry about it. So now that Astro has been installed on my laptop, the next thing you want to do is go through this and use the Astro dev init. Now if you want to use that learning Airflow, you have some templates and stuff like that, but we're not going to be doing that. We are much more advanced than that. So yeah, let's do Astro dev init and create a raw project by ourselves. Astro dev init, yeah. So in our case, it says this is an empty directory. Do you want to initialize the project in here? Yes, thank you. And you can see by default you have mostly everything you need. You have the DAGs, you have the plugins, include test, and every other things that you probably would need if you are setting it up by yourself. It's kind of straightforward. Takes the effort and the bandwidth away from me. That's a plus. Thank you very much. So if you just take a look at the Airflow settings, these are where you can set up the settings, the connection. So we're going to get to this much later. But if you look at the Docker file, you're using the Astronomer Astro CR Public Azure CR 3.07. Essentially, this is what you're using. And you can see the readme and stuff like that. If you look at the requirements, nothing is here. We're going to be adding some information into that. And for our DAG, you see example DAG. Now, okay, once that is done, let's take this for a spin and ensure everything works fine before we get started. So you just Astro dev start. Now, this is going to be the image. Just a little bit. I'm going to increase the size of my screen just for other users that have reached out to say I need to make this size a little bit bigger. And also my terminal should be a little bit bigger. Is that possible? Yeah, that's possible. Great, thank God. All right, now my terminal is bigger, my code base is bigger, ID is bigger rather, and then you can see that the project is starting up. And if you go to your Docker dashboard, you probably will see in your containers something is starting up in here, and you can see in here you have Astro sales forecasting pipeline D7A402. Now that is very important. The name is very important because we want to add a functionality to this to extend it. Just like I mentioned in the architecture, don't forget I said I will keep repeating, referring to essentially what I've mentioned before. All right, so this is our API server, and if you go to localhost 8080, all right, and I'll just copy that, paste it in here. You see that, or you just click on the link directly from here in the API side. You click on the port, it takes you directly to the UI. And welcome to Airflow 3.0. I know this is probably the first time you'll be seeing Airflow 3.0 on the channel, but this is really a beautiful UI and a game changer. Most of the things that you probably don't have as expected are now being implemented in here. Yeah, I won't go into the details of what have been added and all that. That will be a separate video. But yeah, this is a beautiful UI, and the features are kind of top notch. Yeah, you can try to trigger this and see what that look like. I turned it on, and the DAG starts running, and you can see in the runs tab that what is currently running in here. So if I click on that, you see a lot of DAGs that have been created, and if you check the chart in here, you see that a lot of tasks are getting repeated a couple of times in here. So you see that 12 tasks for print astronauts craft. If you look at the logs, let's see what the log look like. If you click on get astronaut and you click on the all runs by default, let's say print astronaut, each of them you see that somebody is currently flying to Tiangong. I'm going to increase this size a little bit to cater for other viewers as well. And you can see that yeah, this is working just fine. Again, each of them have yeah, the work that has been done for them. Yeah, now we don't need a DAG, this example DAG. We actually need to write our own separate DAG. So let's do that and get into the meat of the project. Okay, from here we can now start our implementation. So we start with the architecture, of course, by default, and don't forget we said we're going to be extending the Docker Compose that comes with the additional services that will be adding to Astro CLI, so we can control with Astro dev start and all that. Yeah, so in our case we go to our root directory, and in here if you type in ls or you want to see what's going on, you see that this is the root directory. And if I just touch if only I can type touch, I have docker compose dot override, in this case .yaml. So what we're trying to do is we're not trying to replace the the root directory that we the root images that we have in the in Astronomer. But what we're trying to do is extend the functionality. So whatever image that we are creating right now is not going to be replacing anything. It's just going to be extending the functionalities across board. So let's start with the services. Yeah. So the services that we want to create in this case is going to be mean IO. I'm going to just disable my auto completion, but for some reason it kind of yeah, let's see if this works just fine. I have mean IO latest, Linux ARM64. The server is data console. Yeah, that's fine. Mean IO, that's fine. The root user is fine. Then yeah, that's fine. I can use this as my yeah, the volume is fine. Then the networks in this case is going to be yeah, let's leave it at Airflow and default, and you understand why just in a little while. Don't worry, I'm going to explain why. And then I think one more thing to add might be a health check. Yeah, so let's have a health check. So in our case, we have a test. It's going to be cmd call. Yeah, that's fine. And then the interval is going to be 30 seconds. The timeout is going to be 20 seconds. Then retries is going to be 3. Great. So that's all. I'm going to minimize this for now. That's going to be for our mean IO. Now let's get our ML flow into the picture. Yeah. So I'm going to just start with the MC init, which is the bash. What's it called? The MC init for our mean IO, not the ML flow. So I'm gonna just say mean IO MC. I'm gonna put this back, and then this is gonna be of image of mean IO MC latest, and it's gonna be depending on mean IO, which is especially what we're expecting. Yeah, and the condition on the dependency is gonna be healthy. Yeah, that's fine. Let me see. Yeah, that's fine. Then the entry point is gonna be okay. I'm gonna change the entry point, so because that's not yeah. Let's say the platform is Linux ARM64, and depends on, it's gonna be mean IO. The condition is healthy. Then I have entry point. So in entry point, I'm going to have, let's see, bin sh. Yeah, I'll just change this. So instead of bin sh, I'll just replace this. I'm going to say MC alias to create a bucket. Yeah, so in this case, before that, I'll say I'm setting my alias of mean IO, so I'll call this my mean IO as the URL, the username, and the password. Make sense? Don't forget, if you want to you know, make this a little bit more secure, you have to read this from the envs to make it more secure. So I'm going to create a bucket. I'll call this MB my mean IO. So instead of Airflow, I'm going to call this ML flow artifact. Yeah, and of course I'm going to put true in here to ensure that we get a true response. We have MC anonymous and then anonymous. Yeah, and I'm going to be setting this to public, my mean IO ML flow artifact. Good, and I can exit. So so if you use public in here, you might run into issues. So that's why I'm using anonymous. So please, once you set your mean in here with the credentials, you should be fine to use them anonymous by default in here. So please look into that in case you run into issues. All right, so that's my mean IO implementation. So let's get into our ML flow and ensure everything works fine with our ML flow as well. So the image is going to be Python 3.11 slim, as minimal as possible. The command that we're going to be using is going to be, let's see if this is what we're expecting. Okay, so we have yeah, let's see if we can change this. We have the bash. Okay, I'm going to change this. This is not what I'm expecting. This is probably why I don't like this auto completion. It just make things a little bit slow sometimes. So I'm going to have pip install. I'm going to be installing ML flow, of course, 2.9.2. But if you have a latest version, usually you won't have any issues, unless it's like a major, like 3 point something, that you probably would have some compatibility issues or something like that because of the libraries that are changing. But most likely you won't have any issue. So scicop g2 is what I want to type, but because I was talking, so scicop g2 binary, of course, and then boto3 for boto3 communications. Then I'm gonna have, and just to break that down, and yeah, just tab this up, and I'm gonna have export MLflow S3 endpoint as MinIO 3.9000, yeah, and the MLflow server is going to be host. The reason we want to use this host is to make sure that we can communicate with it from outside of the system. 5001, you can change that if you like, but yeah, I'll leave it at that. So the backend store URI is going to be Postgres, of course, because we're using MLflow. We don't have, okay, by default, MLflow has so Astro CLI has Postgres that comes with it, and the username and password is will be MLflow that we want to use to connect to it, and yeah, that will be fine. And the default artifact, I'm going to show you how to change those things. Default artifact directory is going to be S3 MLflow, and we need to serve the artifact. Okay, serve artifacts. All right, I'll leave it at that. Okay, so that's our MLflow. Then for ports, it's going to be port 5001 as promised. Okay, and then the environment is going to be MLflow. Yeah, let's get some environment in place in here. AWS access key ID, that's going to be required, of course. We need that MinIO admin. The access key and the secret key will be MinIO, the username and password to MinIO, yeah. Then we have the default region. It's going to be US East 1, which is usually the default credentials. We have the MLflow S3 endpoint URL. It's going to be this. Good, that's all we need. And then we have our depends on, so we'll be depending on MLflow DB, which is what we need to create right now, MLflow DB, and then MinIO. So we need our MinIO to be ready. All right, and the networks is going to be Airflow and default. Okay, cool. Now so we need to attach a Postgres that is going to be used by MLflow, of course, in this case, because we need to store the data somewhere. So we have MLflow DB, and that's going to have an image of Postgres 16 Alpine. Postgres 16 Alpine. I'm going to leave that as Alpine in here. And then the platform is going to be Linux ARM64. The environment is going to be, I'm going to have Postgres user. Yeah, that's fine. My password is going to be MLflow, and the DB is going to be MLflow, just like we specified in here, username, password, and the MLflow. So this is not necessarily replacing the Postgres that comes with our Apache Airflow. So we're just making sure that our MLflow DB has the right credentials in here. All right. So for our volumes, we're going to be having a volume created. If you can still recall, in here we said we're going to be creating a couple of volumes like this, all these volumes that we were talking about. All right, we have MLflow DB volume. I'm going to change this to volume. It could be data as well. I mean, so I'm a creature of habit. And health check is going to be CMD PG is ready, MLflow. Good. Then the interval is 5 seconds. Then the timeout is 5 seconds. Good. And then let's add a retries to that. Retries is 5. All right. Network is going to be Airflow and default, and then we keep restarting unless we stop it. All right, that is all we need to do for our MLflow, and we need to get what's it called, Streamlit into the picture. But once we get to Streamlit, we're going to update that in this case. But for now, let's leave it and let everything run as expected. So our volumes that we'll be creating are going to be MinIO data and MLflow DB volume. All right, those are the two. And then our networks that we talked about just now is Airflow external, and then we're going to give it a name, Astro sales forecasting. Is it Astro sales forecasting pipeline Yeah, and then what's the name? If you check in here, we have Astro sales forecasting dash pipeline underscore D7. So we say underscore D7, yeah, A402, A402. All right, D7 A402. That's the one. Astro sales forecasting pipeline. Astro sales forecasting pipeline. Yeah, this is very important because you need to make sure that it works. The keywords works fine, and you don't necessarily need to run into any issues once you make sure of that. Then this is going to be, the name is going to be by default. It's going to be, yeah, name is going to be Astro sales forecasting pipeline D7. Yeah, default. Yeah. So this is very important. This particular thing is very important because if you don't have them on the same network, it's going to be difficult to communicate with each other, each of the services in this case. All right, that's all we need to do, and let's check this out and ensure everything works just fine as we proceed. All right, we've opened the terminal again. We say Astro Dev Start, and this is going to build a new image with all the new services that we've just created. If you look at our dashboard and on our Docker dashboard, we have just 6, yeah, 2, 4, 6. We have 6 services running right now. At the end of this project starting up, you'll be seeing much more services that are starting up and all are communicating together as correctly. Okay, let's check it out. So you have our project has started. Airflow UI is now ready, and you can see in our Postgres DB is connected to that, and the default DB credentials are this. These are all that gets created automatically once you start up the project. And in our Airflow UI, you see that we have a new UI. The DAG is running as expected, and if you check our new services, all of them now are running together. If you look at the MLflow DB is here, MLflow is here as well, MinIO is here, and you can check that on the UI to see what that look like. The MinIO admin is the username and the password is MinIO admin. So if you log into that, you see our MLflow artifacts created as expected. So this is something that we expect as type of validation to make sure that everything works just fine before we even continue or even get started with the rest of the coding. If all of this implementation is not in place, we might have to struggle a little bit as we go along. But yeah, at this moment, everything seems to be working just fine. So yeah, that's a good a plus. All right. So now let's continue, and we can set up continue setting up the project to ensure that everything works just fine. So now let's create our new DAG. In this case, I'm going to create a new DAG. I'll call this, yeah, okay, I'm going to touch DAGs, and I'll call this maybe call this, what should I call it? Sales forecasting, sales forecast training, yeah, .py. Yeah, in here I don't need the DAGs, the sample DAG, so I'm just going to remove DAGs and remove the example DAG. Yeah, so that's not required. Now in my sales forecasting DAG, to get started with that, usually in Airflow 2.0 you say import DAG.DAG and stuff like that. It's a little bit different in here. So you have from let's get the date time in place, which is the time delta, and I'm going to need Airflow from yeah, for syntax analytics, syntax highlighting syntax highlighting. I need to install Airflow. So pip install Apache Airflow. This is going to install Apache Airflow latest, and it's going to resolve all the highlighting issues that I'm seeing. The scribbles just below the Airflow in this case. Yeah. Okay, so it takes a few seconds for that to reflect, and that should fix whatever issues that is left with that. So I'm going to have from decorators, I'm going to import DAG, and I'm going to be needing a task as well. Then yeah, at the end of the day, I'm going to be needing pandas, import pandas as PD. yeah, but for now, and yeah, let's leave that as it is. So in my requirement.txt, just to make things easy and simple, let's get our requirements in check to ensure that we take care of all of the required dependencies. So let's start with the ML data and processing. So I'm going to be needing pandas to do that. Pandas, yeah. I need NumPy as well. I need SciPy. I'm going to need scikit-learn, of course. Then I need XGBoost, LightGBM. Prophet is kind of debatable, but yeah, we need Prophet as well, and Stats model. And this is because some of these we'll be needing them as we are processing the machine learning pipelines. All right. So for our experiment tracking, yeah, we need MLflow and Boto3. Now for data validation, we'll be needing Pandera. If you don't know what Pandera does, please go through the documentation. So it's going to be required in this case. For feature engineering, I'll be using category encoders, and for model validations, model serving and API, I'll be needing fast API for that. UVCon, Pydantic, yeah, HTTPX. All right. For visualization, I'll be needing Matplotlib, Seaborn, and Plotly. Maybe not all of them might be useful at the end of the day, but I'll be needing the three just to be able to switch as required. For my database connections, I'll be using SQL Alchemy, PsycopGB, and PyMongo. Well, PyMongo is kind of debatable. You don't need PyMongo necessarily because I'm not using MongoDB. So yeah, but let's add that to it. But that's not required, to be honest. For my cloud storage, I'll be needing S3FS. So you don't have to use Boto3. Yeah, maybe for testing PyTest, if you have enough time. Additional utilities that we'll be needing is python.env to read from .env, PyYAML joblib for exporting models, Optuna for optimization, Sharp holidays to get the holidays in place, and from UI we'll be using Streamlit. I know it's a lot of libraries, but yeah, so these are the libraries that we'll be using. So to make things easy, I'll just install them beforehand. I'll be installing all of them through requirement.txt. And if you had to install this manually, you can rewrite the requirement.txt and it's going to install all of them. This is going to be installing the latest versions of this library, so you should be fine if you're using Python 3.10, but if you're using 3.13, you might have to look into some of those libraries. So for reference sake and to make things easy for people that will be watching this video much later, I'll be exporting the exact version that is installed for each of these libraries to this requirement.txt, so you don't have to run into issues again. Okay, that seems to be done, and easily you can continue from here and make sure that whatever you're writing, whatever library that has been installed is correct. So to make sense, this is the simplest version that you probably get, but in a case where you need the actual version, I'm going to just maybe copy paste this just to I'm just saying I'll put this as .raw, put this here, and for the actual versions, I'm going to just do pip freeze and write all of them to requirement.txt, and you'll see that there's a lot more libraries in here with the actual versions that are used. So if anything changes in the future, all these libraries, so far they work right now, you should be able to replicate and build them successfully. Yeah. So that's essentially what I'm trying to do in here. So that's my requirement.txt. Now that the requirement is ready, I'll just put this, I'll change this name to actual dot versions, right? And rename this back to actual, yeah, which is the requirement.txt. So if you need the actual versions, you can use this. If you need the raw.txt, that's fine. All right, now let's go back to our sales forecasting pipeline that we're using to train the model to ensure that everything works just fine. So back to this model, we have the DAG rather, not the model. Yeah, so we have this in place. Now let's get our sys in place. Import sys. I'm going to be adding some include directory, so because include by default may not necessarily be there, so I'm going to do sys.append, sys.path rather .append, and I'll be appending every library that's inside of user airflow include. All right, now let's get our default argument. We'll be iterating this to ensure that everything works fine at the end of the day. So we have our default argument. So the owner in this case is going to be data team. I'll call this code with you. Yeah, and then this depends on past. It's going to be false. The start date, I'm going to put this as start date, is going to be 2025, and August is the month, and the day is 9. All right. And yeah, so if you want to set up the emailing facilities, you can do that, but that's not required at this moment, so I don't need that. Retries is 1, so you don't have to try it multiple times, just 1 minute. And then the retry delay in case of errors is 1 minute as well, so I don't have to wait for 5 minutes for it to retry. Then the schedule interval has changed in Python in Airflow 3.0, so it's scheduled now. It's not, I think it changed in 2.10 as well, so not necessarily you don't need this schedule in the default argument, but you can put it here. So I'll be using the weekly, so we'll be training this weekly or retraining as much as possible depending on our requirement. So let's get our DAG in place. So the schedule is already there, so we don't necessarily need the schedule again. Catch up is going to be false, so we okay, so catch up is also here as well. So I'll just put default argument. Default args is going to be default args. All right, the description is going to be sales forecasting training DAG, and let's get some tags in place. I'll call this, yeah, tags is going to be, I'll put this like this: ML, training, and sales. All right, yeah, sales forecast and sales. Yeah, I think that kind of represents it correctly. All right, I suppose that's all we need to do to get that in check. Now we'll be using the functional approach in this case. So we have dev sales forecast training, and some of these are going to have individual tasks that will be chaining together. If you can recall, in Airflow 2.0 you have task dependencies where you say something double arrows, then you link or you say upstream set downstreams and stuff like that. That has changed in 3.0, and I'll show you how to link it to make it work just fine, so don't worry about it. In here we have our task, so let's get our task in. So our task is going to be open and close bracket. You need to call that function. We have extract data task, yeah, and this is going to be from, yeah, because you don't have that logic in place in here, we're going to create inside of include a data generator. So we're going to say utils.data generator, and I'm going to be importing realistic sales data generator. All right, realistic sales data generator, and I'm going to be outputting the data output directory. And don't worry, we're going to be creating that shortly. It's going to be inside of temp and sales data. Now for our generator that we're creating, it's going to be sales data, realistic sales data generator, and we're going to have a start date. Start date is going to be 2021 0101, and the end date is going to be 2025 0809. Now that's today. So now let's say print generating realistic sales data. Yeah, that's what we need to do. Now let's create this realistic sales generator. That will be inside of our include, and we have that to be utils. So we have inside include, we are going to be making a directory, and we're going to be going into include and call that utils, isn't it? Now, and in our include we have utils, of course, and inside of utils we have our first data generator, and that would have a class. So let's start with that. Yeah, include utils, and I'll call this data generator, isn't it? .py. All right, so that should be there, and in here we can get imports and stuff like that in place. So let's start with the class. So the class is going to be realistic sales data generator. So we have our def inits, so of course, which is the start and end date that we specified. But to make things make more sense in case of failsafe, and 2020, we have 2021-0101, and the end date is going to be 2021-12/31. So if you don't supply the user the start and end date, you use the 1 year record. So we have self.start. Start date is going to be that, the end date is going to be that, but by the way, we need to do pd pandas, of course, to date time. Yeah, pandas to date time for the start date. We do the same for pd what am I doing, pd dot to date time for the end date as well. Good. And you can see automatically it's imported pandas. So yeah, so for the holidays we have US holidays. Yeah, I know I'm in the UK, but yeah, we can use the holidays in the US. So holidays. Okay, if I can only type US. All right, so if you, yeah, I think you have the UK in here, but I'll just put the holidays US in here. All right, so I'll just import holidays. All right, good. Now that's for my init. Now let's initialize our stores. If you're doing this maybe via API or something, I mean, if you actually want to implement this in a business, so you don't necessarily have to have a sales data generator. You just need to have a way to get this similar data in probably in similar structure, and you probably are going to have the same similar results that I'm getting, which is kind of good, by the way. So yeah, but essentially if you have the store API or some other information that we'll be doing, if you have the API already, so you don't have to like hard code them, that's essentially my message in this case. All right, so we have the US implementation in here as a holidays. So let's get the self.stores. It's going to be an array, and I'm going to have store 001, like I mentioned in the architecture section. Then so I'm going to have the location, it's going to be New York. Let's have New York, and I'm going to just change all of this. So size is going to be large, and I'm going to have the base traffic, which is like a regular traffic for a particular location. So let's say 1000 in this case. Yeah, what am I doing in here? So we have, yeah, this is going to be store. Yeah, I'm putting this like this. Yeah, should fix that. Yeah, that's fine. Now for my store 2, I'm going to have this in Los Angeles. Let's put it in Los Angeles. Yeah, the size is medium. Let's put this as large as well. The base traffic is 950. Store 3 is in Chicago, is medium. The base traffic is 800. Right, I keep changing the numbers. We have Houston, which is medium. This is going to be 650. Yeah, that's fine. 650. And then store 5 location is in Phoenix. Let's put this as Phoenix. Yeah, Phoenix. and the size is going to be small. The base traffic is going to be 400, and I'm going to have Philadelphia. Yeah, Philadelphia. The size is going to be medium. Yeah, the base traffic is maybe 500, 600, whatever. It doesn't matter. I mean, I'm just trying to put some imaginary number in here. I'm going to have store 7. It's going to be in San Antonio, and that's going to be small. Yeah, the base traffic is going to be, let's say, 350. Then I'm going to have store 8 is going to be San Diego, and that's going to be medium, and the base traffic is going to be 550. Then I'm going to have store 9 in Dallas. The large is going to be a large size, yeah, and the base traffic is going to be something around 850. And the last one is Miami. Miami. The size is going to be medium, and the base traffic is going to be 600. Good. Now these are my stores. Yeah. Let's get in the product as well. So self.product categories. I'm just going to copy paste that to make things faster. Yeah. Categories is going to be equal to that. So we're going to be selling electronics with 1 2 3 4 5 laptop, smartphone, headphones, tablet, and a smartwatch. For clothing, t-shirt, jeans, jacket, dress, shoes. For home, coffee maker, blender, vacuum, air purifier, and toasters. And as for sports, we have yoga mats, dumbbells, running shoes, bicycle, and tennis racket. So that's the ones. Those are the products that we'll be selling. Essentially, let's see. So that's my electronics. Yeah, and this is closing up the. Yeah, that's fine. Just want to make sure that my indentation is correct. Now for my all product, it's gonna be self. Let's call this all products. It's gonna be. So for categories, for category and the products. In self.product categories, the items, of course, I'm gonna have another inner loop in here, product info, product items, and I'm gonna have this. So let's get this. Product ID is gonna be everything destructured from product info. Product category is gonna be there as well. Yeah, I hope that makes sense. So what essentially I'm trying to do in here is to have all products that are tagged with the category. So if you look at all my products in here, yeah, all my products, I don't necessarily have a category in here, but yeah, a category in this case would have in my all categories. Where is it? Product categories. You can see that they all have a category attached to each of them. This is just like data cleaning. Yeah. So once that is done, the next thing will be to continue. Let's see. I think for now I don't think I need to do anything else. So let's just get our sales data function in place. Yeah. Let me see. I think that will be my initialization. So that will be all. Let's get in our sales. So in case we want to generate the sales data, we're going to need for now. In fact, I'll just do that much later. So let's go back to realistic sales generator. So here we are generating the sales data. I'm going to have file paths for each of the data that is generated. I mean the package file in this case. I'm going to have generator generate sales data. So I wanted to before implement the function before calling it, but I think it makes sense to call it first before implementing it. Yeah. So generate sales data, and in here my output directory is going to be the data output directory that I just created in here, sales data. Now let's get the sales data in here. So generate sales data. Yeah. Okay. So the first thing I need to do is OS make directories. Yeah. It doesn't look like I have OS imported. I do. So yeah, that's automatic. So I'm going to have output directory. By the way, I need to fix the the arguments in this case. So the argument that I need is output directory, and that's by default it's going to be a string and linking to TMP sales data. So if I don't have this data supply, this is going to be the default, and this is not going to be only string. It's going to be a dictionary that is returned. I'm going to have a string and a list of string. Yeah, a list of string. Okay, so let's import. I think I should import from typing dict, and for list I'm going to import the same as well from typing. Good. All right, so that's all I need to do. Now let's continue our sales data generation implementation. So I just created a directory. If the directory exists, okay, it's going to be true, so we don't have to override that. Now let's generate the supplementary data. Supplementary data. I'm going to have promotions df. It's going to be self dot of course generate promotions. We don't have it right now. We're going to create that promotions, and then for our events we have store events df. It's going to be self dot generate store events. Yeah, so those are the two functions that we'll be creating now. So let's start with the generate promotions. We don't have it, so let's create one. I'm just going to minimize this for now. So I'm just going to have dev generate promotions. It's going to be self. Yeah, by default it comes with it. pd.data frame. So I'm going to have promotions, and let's see if this makes sense. So I'm going to have, yeah, before that, so let's have our major events. So major sales events, so we have a couple of events that can happen, and that would be something like Black Friday. Yeah, we can have Black Friday, which is usually in November. Black Friday, and I'm gonna have 11 in, that's what's it called, in November. Yeah, that's 11. Then it happens, it goes on for the 4th Friday, yeah, and the 5th, and so, okay, again, so 11th, it happens on the 11th, which is the 4th of Friday. So how do I make that make sense? So again, Black Friday happens in November. It's the 4th Friday in November, yeah, and it happens for 5 days and it has 25% off. Okay, so again, let me just put it here to make it make sense. So I have the 4th Friday of November, yeah, and it goes on for 5 days and it has 25% off. Yeah, that was what I was trying to explain, but kind of, I don't know, it just I hope that makes sense now. The same thing happens for Cyber Monday. So there's usually Cyber Monday, and I know this because a couple of friends in the US told me some of these things. Yeah, so we have 11.4 to 0.20, and the same thing is going to be the Monday after Black Friday. Yeah, so 2 days and 20% off. Yeah, so I'm gonna have Christmas sales, Christmas sale, and that's gonna be 12 December. Yeah, that was 15, 10, and 0.15. Essentially, that's just gonna add a comma in here. 15 December for 10 days and 15% off. The New Year's sale is gonna be 10. Yeah, let's put it as 20% off. Okay, and just for clarity, I'm gonna have this added to that. 1st of January for 7 days, 20% off. So we have another one, President's Day. I suppose this is not something that the UK people can relate to. So it's gonna be 215 for 3 days, 0.15. Well, you can create or imaginary major events, so you don't have to necessarily have to follow this process, but yeah, it's just something that I think might be Memorial Day. I'm just leave it at that. And Independence Day, let's have July 4th. July July 4th. So yeah, let's leave it at that. I mean, you don't have to necessarily follow everything in order, but I suppose if you did, it's gonna make things easier for you. Yeah, no, I'm gonna add comma to that, and that seems to be the major events that we want to take care of. All right. So let's have a current date. Current date is gonna be the start date. So while current date is less than or equal to self date, let's have the event month, event name, the month, the duration. I'm going to change this month, then the day, and then the duration, then the discount in major event. So you're going to have if event name is going to be equal to Black Friday. Yeah, if the event name is Black Friday, then this is maybe slowing me down at this point. So I'm gonna have November. It's gonna be pd.timestamp. No, timestamp. Yeah, it's gonna be year, 11th, and the month. Yeah. Then the Thursdays. Wait, what am I doing? Equal to, yeah. By the way, I think I need to get the year in here. Current date dot year. That should be fine. Okay. Now for Thursdays in November, Thursdays, it's going to be pd.date range to extract the Thursdays in November. So I'm going to have November. The periods is going to be again November plus time delta of 30 days, yeah, and the frequency is going to be weekly. Yeah, frequency is going to be weekly on Thursday. Yeah, so let's import time delta in this case. All right, and that will be from date time. All right, so that's my Thursdays in there, and the event date is going to be Thursdays day -1. No need for that. I'll use 3 plus time delta 2 days equals to 1. And this is going to give me, so it's days equal to 1. So that's going to give me the 4th Thursdays of November. I hope that makes sense. Okay, maybe you have a simpler approach to get the last Thursdays in Friday, but I suppose that can work as well. But yeah, this worked fine. So I'm gonna have else. So I'm gonna have try to event date. It's gonna be pd.timestamp.year, yeah, which is the year, month, and day. Then accept the value error. Just continue. All right. Most times you won't have value error because we are doing it manually, so it's fine. Okay. All right. Now, if self dot start date is less than or equals to event date, and is less than end date as well, then for D in range of duration, I just want to get the actual dates in this case. All right. So for those dates, I'm gonna have promo date is gonna be event date plus timestamp for the date. Yeah, so if the promo date is less than or equals to self dot end date, then our promo product is gonna be random dot sample. Yeah, listen, just import this, import random. Yeah, import random. Yeah, random dot sample self dot all products dot key. Get that, and then it's gonna be random dot rand int. All right, 5 and 15. And for each of these products, for products ID in promo products, just generate a promotions in there, promotions.append. I'm gonna have product ID. Yeah, that's product ID. The promotion date is going to be date, so instead of promo date it's going to be date. I'm not using promo date. Yeah, then the discount percentage, discount percent is going to be discount. Yeah, let's add one more as promotion type. Promotion type is going to be event name. Yeah, so I have product ID. So essentially what I'm trying to generate in here, that may look somehow, but essentially what I'm trying to generate in here is for each of the dates I'm going to be sampling some products and applying some promotions to them with the percentages. That's what I'm doing essentially, nothing extra in this case. Okay, all right, now let's go back. Just before this, I'm going to have current dates. It's going to be current date plus pd.date offset. Yes, equals to 1. All right. All right. Okay. Then just below this I'm going to have end flash sales. Sometimes you can have flash sales. It's going to be int of self.end date minus self.start date, days 0.5, so that's like 5% of the year, 5% of the time. Yeah, then I'm gonna have flash dates pd.date range is gonna be self.start date, self.end date, then the period is gonna be flash sales, isn't it? Periods is gonna be end flash sales. Yeah, so for dates in flash dates, promo products is gonna be random samples, get the keys, the k is gonna be random int, and we can get between 3 and 8. Yeah, and that should be fine. Now for each of these 3 or 8 products, so I'll just get the same thing, but in this case promotion type will be random. So the discount percentage, I don't want to fix it at 95, so I'm going to have random.uniform. I'm going to have 0.1 to, so that between 1 and 3%, I'm going to have those off. Yeah, if you just want to document that, so 10% to 30% discount, not 1% rather, it's 10% to 30% discount. All right, so at the end of the day, I'm going to have return pd.data frame with the promotions. Okay, yeah, that seems like a lot, and yeah, we can test the promotions out to make sure that we're good to go, but not necessarily. I think we can just proceed. Let's do the same for store events. So I'm just gonna cut to the chase and quickly do the store events in here. All right, so for store events, essentially I'm trying to do the same thing. So I have the events that I want to generate for. So I have each of the stores, so in this case store ID and the store info, which is what I have in the store items. If you can still recall, in my stores I have store, I have the location, the size, and the rest, like that. Yeah, so in my store events I'm saying the store and the store events, store info. So the first one will be store ID, the rest will be store info. In this case, any number of closures could be weather, technical issues, and all that. Then I have the closures for each of these closure dates that will be happening. So I'm going to put this in a loop to have each of them to have 100% reduction when it's a closure, so there is nothing on that date that we have. But if it's say renovations is going to be 30% chance of renovation, which could happen at any point in time. So I'm going to have renovation start date, which is when the renovation will be starting. And that's going to be the start date plus a random integer of days between 100 days and 600 days. Yeah, and sometimes you want to upgrade a store, you have to close it down to upgrading, or from small to medium to large and all that. But most times, some minor renovations do not necessarily have to affect the store in terms of closure. Most times it's just like one side, but most renovations have to like stop the entire operations of that particular store. So I have renovation duration is between 7 and 21 days, and each of these duration is going to be this. All right, so 30% reduction is going to be what I have, and that was what I was saying. It's not necessarily 100% closure, but in a case where there is, the impact is going to be 30% reduction of whatever sales that comes from that products that comes from that store. All right, and I return that. So essentially, I have the both promotions and stores events at this point. Well, that's hypothetically. Once we run it, we can actually be sure that everything is properly implemented, and we can actually test it out. All right. Now, once I have the stores and the promotions, the next thing will be to now generate the locations of the file path. So I have file paths. It's going to be let's put this here. So I'm going to have my sales. It's going to be inside here. My inventories is going to be here. My customer traffic is going to be here. Promotions is going to be there. Store events will be there. All right, now let's start storing each of them as we go along. So we start with the what am I doing? So we're going to start with the supplementary data, and that will be promotions path. It's going to be os.path.join, then the output directory. We're not saving in CSV. We're going to be using Parquet file, so it's going to be promotions/promotions.parquet. Yeah, am I doing the right thing? Yes, looks like it. So I have promotions path, os path join, output directory, promotions, then promotions.parquet. That's fine. So let's make a directory if it doesn't exist. If it does, it's fine. Then promotions ZF, then convert that to Parquet. We don't need the index to be true, it's going to be false. Then the file path is going to be promotions.append, then we append the promotions path. Yeah. Then events parts, the same. We need to do the same for events parts. So it's going to be store events into events.parquet. All right, not store events.parquet. So we have os.make directory, the same thing, store events, event path. All right. So let's generate the sales data. Let's put it here. Generate sales data by day. If I can only type day. All right. So the current day, I think we already had that. So which is the self.start date, current date. Yeah. So while current date is less than or equals to self.end date, we're going to have the date string. It's going to be current date at time into year, month, and day. Makes sense? Logger.info, we're generating sales data, but we don't have logger implemented, do we? So let's get that in check. It's just a quick one. Yeah, that should be fine. Import login. Yeah, that's taken care of. Now at the bottom here, let's continue. So we are saying generating sales data, isn't it? Generating sales data for that, and I'm gonna have daily sales data for all stores. That's gonna be gonna put that inside here. You can have daily sales data. It's gonna be this. Daily traffic, daily traffic data is gonna be this, and daily inventory data is gonna be that. Okay. Now for each of the store and the store info in store items, exactly. So we are going to have a base traffic. Yeah, our base traffic is going to be that, and then the dates, yeah, which is the date factor. So let's have a let's put in our date factors in here. Date factors. It's going to be DOW factor, day of the week. Yeah, day of the week is going to be self.get day of week factor. So we need to quickly implement this function. So if I have this up here, just below our promotion, above our promotions, yeah. So I'm just gonna, you can put it anywhere. So this is just me being petty. I'm gonna have dates is gonna be PD timestamp. So I'm gonna have day of the week is gonna be dates.day of the week, and then the DOW factors is gonna be 0.9. So what I'm essentially trying to do is I'm going to rank them in the day of the week, yeah, which is the Monday to Sunday. So Monday is going to be 0 and the Sunday is going to be 6. So I'm going to have 0.9, 0.85, I mean 0.85. This is just random number that I'm plucking from thin air, so there's nothing, no statistics that is backing this up or something. And 1.2, yeah. So I have 1, 2, 3, 4, 5, 6, 7. So of course, you know, the index starts from 0. So I'm going to have return DOW. So that's the day of the week factor, essentially. Okay, so once I have my day of the week factor, then if it is holiday or not, it's holiday in the US holidays. Now the holiday factor is going to be 1.3 if it's holiday, else 1.0. It's just like to boost it a little bit. That's what we're trying to do in here. If there's a weather impact, so weather impact, and this is going to be random, so just so I'm clear, I don't have anything that is backing this up essentially, but in some cases you have some cases where you have weather affecting the sales of a particular local store that you currently have. So I'm going to import this numpy, and then of course weather factor is going to be it's going to be the max of 0.5 and the minimum of 1.2 and weather factor, just to be sure that we have between 0.5 and 1.2, so it's nothing above that. All right, okay, that's fine. Now let's check for the store events. Now check for store events. So we currently have store events, which is going to be so let's say store events. Let's start with that. I don't know what it's trying to do in there. Store event impact is going to be 1.0. So let's say this is like a total store event of 1.0. Now if we have a store event dot empty, if the event is empty in our store event, we're going to have the impact is going to be, let's say, event store event impact df. What's our event df in here? What's it called? Store events df, isn't it? So store events df, that would be store event df. Yeah, I'm gonna have store events df, then the store ID is going to be that, and the store event date is going to be that. Yeah, just to make sure that whatever date we have and whatever store ID we have, we get the store event. Yeah, this is just basic filtering of a pandas data frame. So if there is no event dot in that case, then of course we have impact is going to be plus 1.0. I hope that makes sense. So if there is no event, it's going to be 1.0 because it's going to be 0. Otherwise, it's going to be 1.0. Okay. Now, I think that's that. And the only thing that I think is left is the store traffic. So I'm going to put this in here and say calculate store traffic. And the store traffic is going to be an integer of the base traffic multiplied by day of the week factor, multiplied by the holiday, multiplied by the weather, multiplied by store event impact. That makes sense. And then we need to multiply this again by a random number between, let's say, 1 and 0.5, just to make it a random, to normalize it. mp.random.normal, and that will be 1.0, and let's put it at 0.05 rather. So yeah, I'll just break this down here so it's visible at once. Now for my daily traffic data, I just quickly append all of this. Store ID is the same, the date is the same, which is the current date. Yeah, current date. Then I have the customer traffic. Traffic. It's going to be store traffic. The weather impact is going to be weather impact. It's going to be weather factor. Just add a comma to that, and weather factor. And then is holiday. Yeah, I hope that makes sense. We're just creating the daily traffic data. And then for the product level sales, generates product level sales data. It's going to be for product ID, the product info in all products. Yeah, so we get that. So if you want to add seasonality factor, this is where we probably will do that. In this case, before we calculate the product sales, we are going to have something like product seasonality, and those seasonality. Yeah, so for those products that we have the seasonality, we're probably going to consider them in this case. Yeah, something like this, where we say if it is back to school, if it is this, if it is that, if blah blah blah. You can do that in here. But I don't want to break anything in here because I didn't really factor the seasonality in check. But I'll just comment this out for now. We can enable it much later, but for now let's just continue. I'm going to have check for promotions. All right, in this case, so the promotion factor, promotion factor is going to be 1.0. The discount percentage is going to be starting from 0, of course. So if there is no promotions that is applied on that particular day, then there's no need to check. But if there is, we need to filter that out and get the promo for that particular product and that particular day. Yeah, so if that is empty, then 1.0. Otherwise, whatever percentage that you have, you subtract that from 1.0, which is like 100%. In this case. Now, in this case, we want to have the promotion factor, because there will be a multiplier demand if you apply a promotion. So let's say you are selling something for 100 quid and somebody comes, which is $100 rather. We have $100, so you have a discount of 20%. Because you've applied a percentage discount on that, you probably will have more sales on it. So because of that, I'm gonna put that promotions increase demand. Yeah, so in our case, instead of just subtracting directly the percentage, we need to have a multiplier factor. So I'm going to have 1 plus discount percentage times 3. Yeah, so that would be my promotional factor. In this case, I'm applying a 3 times multiplier. Okay. All right. So essentially, that's what we need to do for the production. It's rather not production. Yeah, let's now apply that. So I'm calculating the rest. So if it is a size factor, in this case, let's just put this as sales quantity. I say sales quantity. So based on the size is going to be, whenever it's large is 1.0, medium is 0.7, small is 0.5, and this will be based on whatever store info size that I have. Yeah. Then my price, maybe I should just flatten this out so it doesn't necessarily increase my, yeah. Then I have my price factor. My price factor is going to be 1.0 divided by, I mean, this is just normal calculation I've done beforehand, so it's easy for me to regurgitate this. Otherwise, you might have to do your own calculation by yourself. So this is going to be product info on price divided by 100.0. So, and the reason is because when you have higher price, you're going to have lower volume. It's kind of it makes sense, right? So but if you have lower price, you have higher volume, which is something like the promotion factor. All right, now the base quantity that we want to sell, base quantity is going to be store traffic. Yeah, store traffic multiplied by, let's say, 0.001, multiply by the size factor, and multiply by the size price factor. Yeah, so store traffic 0.01, size factor, and the price factor. So the quantity at the end of the day, is going to be an integer of the base quantity multiplied by, in this case, if you have a seasonality factor, we can add it in here, seasonality factor, but we didn't calculate that, so maybe we should, but I mean, yeah, maybe we should just do that. Base quantity multiplied by seasonality factor, multiplied by promotion factor, multiplied by random between 1.0 and 0.2. Once we've gotten the quantity, the next thing we want to do is ensure that we calculate the revenue from there and then export the data. Essentially, that's essentially what's next to do. I'm just going to say calculate revenue. In this case, I'm going to have actual price. It's going to be product info. And I'm going to extract price from there, and I'm going to multiply that by 1 minus discount percentage. Yeah, so the revenue in this case is going to be quantity multiplied by actual price. Essentially, what we're doing is trying to calculate the actual sales for a particular product. So the cost is going to be quantity multiplied by product info. For the price, multiply by 1 minus product info margin. So for the margin, so that will be the cost. So in this case, if the quantity is greater than 0, we can just get our daily sales data and append data into that end to end. So in this case, let's look at it. Daily sales data. We have the store ID. We have the date, store ID, the product ID. Let's get the category into the picture. So we have the category. It's going to be product info category. We have the quantity sold. Let's put this into as quantity sold as the quantity. we have the unit, don't we? Let's get a unit price. Not unity price, is unit price. That will be the price. And we have the discount percent, which is gonna be next to that. It doesn't matter, the order doesn't matter. This is an hash map anyways. So we have the revenue, we have the cost, and then we have the profit. Let's get the profit in here. So the profit is going to be the revenue minus cost, isn't it? Revenue minus cost. Essentially, that's the profit. Yeah, so that's going to be where our quantity is going to be. The next thing we want to do is just make sure that whatever we have in this case for our quantity, we want to make sure that our quantity is always greater than 0. So we're going to have quantity is going to be the maximum between 0 and quantity. This is very important to make sure that our quantity is not 0. Otherwise, it's going to affect the total sales. So ensure that before you calculate the multiplication here, you check the quantity to be greater than 0 in that case. Okay. Now, once you have a quantity that is greater than 0, the next thing is to do inventory level tracking. So in this case, I'm going to just put this as yeah, I'm gonna say this is gonna be the inventory tracking. So we have the inventory level is gonna be the let's put this as random integer, isn't it? Random, that's rand int. I don't need the integer of base quantity. I'm just gonna put the random integer between 500 and 200, 50 and 200 rather. And the reason is because we are not actually using the real data, so we just want to make sure that the data is as close to what we're going to have as possible. So the other point is going to be random.randint between, let's say, between 20 and 50. Yeah, so daily inventory data dot append. We append the data, the store ID, the product ID, the inventory level, the reorder point. Yeah, and let's add one more in here and call this days of supply, and that would be inventory level divided by the maximum between 1 and the quantity. That would be our reorder days of supply. Okay, cool. And that's all we need to do. The next thing is just to export this and save it properly into the partition. So I'm just gonna go back into the generate daily sales and say let me just put a comment in here to make the the daily files what save daily files with proper partitioning, essentially. Partitioning, yeah, if only I can type that. So we're gonna have if daily sales data is existing and there's data inside of it, we say get the daily sales data. Then in our case, sales path is gonna be os.path.join the sales.parquet. But before we do that, we have the output directory. Instead of putting this directly, we're gonna put it as sales for year is going to be current year / the month is going to be the current month, and let's format this into 0.02d just to make sure we have the month correctly, and the current, that will be the current month. Yeah, then we do the same for the day. Yeah, that's the month, and then for the day we have same thing, 02d / let's see. Yeah, I'm just gonna put that in there, minimize this a little bit. We have, yeah, again, current year, the month is gonna be the days / the day, and then we have, yeah, year, month, and day, isn't it? / let's add a / in here, and I'm gonna add sales. I don't need this anymore. It's gonna be sales, and let's add a date string into that. Date string dot parquet. Yeah, essentially that's all we need to do. Let me just be sure that we're doing the right thing. What's this? It says date variable might be referenced before assignment. Let me see, where is this in? Yeah, I think I need to move this. Yeah, that's it. So it should be inside of this bracket. Yeah, inside of this while loop. Yeah, this inside of this while loop is where the daily sales data, that's why he was complaining before. Okay, so once we have the sales data in place and we are exporting it correctly, the next thing is just to make sure that we make the directory and we export it. Okay, os.make directories. If the inventory part exists, we do that. Otherwise, sales data exists. We're going to do that for inventory as well, but yeah, we have the os make directory for sales part exists. Okay, and then we have sales df to paquet, that's fine. Index is false, file path for sale is appending that, that's all. Then we do the same thing for our inventory and the traffic as well. So we have customer traffic data. It's going to be if daily traffic data, essentially the same thing. We have customer traffic, yeah, the year, the month, the day, yeah, and then customer underscore traffic. We don't need this here, it can just be traffic directly, traffic dates, and that will be fine, and that will be writing into customer traffic. That's good. Now let's do the same for our inventory data. Okay, so in here we're going to have inventory data, and we're going to have if daily inventory data, and let's add one more clause in here. Current date, day of week is going to be 6, and the reason is because you want to do this only weekly, on Sundays only. Those are the times we want to export, so we can capture all the data for the week. Yeah, only weekly on Sundays. All right, so we have that, and then the inventory data frame will be that. We're gonna have, yeah, that's essentially it. And we have inventory date string, we have make directory, inventory df, inventory. That's fine. Then let's move on to the next day. Yeah, let's move on to next day. It's gonna be so instead of time date offset, I'm gonna use time delta in this case, yeah, for this one. That's all. Now yeah, I know it's a law, but yeah, we need to just make sure that our data in this case is right. So just outside of this while loop, inside here I'm gonna have metadata. Yeah, metadata is gonna be generation date. Generation date is gonna be date time dot now. I can use ISO format for this, so it should be fine. The ISO format. Then the start date is gonna be so import the date time. Yeah, so self dot start date, ISO format. The end date is going to be ISO format. The number of store is going to be the length of self store, of course. The number of products, I'm going to put this inside. End product is going to be the file count is going to be, let's see, I can do the count by using a lambda function in this case. So I'm going to have k is going to be the length of v for kv in file path.items. Yeah, that's it. Then we do the total files. Total files generated is going to be the sum of length of v. Is it? Yeah, file path of value. Yeah, that's fine. That should be it. Yeah, so that will be our metadata. So let's put that in a data frame and export that as well, so we are all good to go. We have metadata df. It's going to be pd.dataframe for the metadata. We have the metadata part as this, and I'm going to adjust this to, instead of just writing directly, I'm going to have metadata / let's call this generation metadata.paquet. Yeah, make directory is fine, to paquet is okay, and then we can just log. Yeah, we can just say logger.info generated this for that. Logger.info, we have sales files. It's gonna be yeah, length of that, and then output directory. Let's put the output directory in there. Well, these are just like not something that is required, so you don't necessarily need to do them. Just return the file paths, yeah, and that should give us the what we're looking for. Why is this underscore? Oh, okay, it's just like English. All right, so this is shadowing data from, so metadata in. So I'm just gonna put this inside as it is. So instead of metadata directly, I'll put it as metadata underscore in. Yeah, just to avoid shadowing the outer variable. I think that's all we need to do in this case for our sales. Now, if you look at where we've gone so far, we've got about 3 things that we need to undo. In here we have the first one is our promotions, the sales, and we make sure that whatever we have in the sales and promotion is correctly populating across. So we have the sales, we have the promotion, we have the customer traffic. Essentially, those are the 3 things that we need to do as related to our data frame, our architecture that we discussed earlier. So, but in our case, once that is done, we can now start proceeding to actual training of the model. Now, these are the raw data that is generated. So the first part of the system is taken care of. Let me show you this part. So this part is essentially taken care of. If you look at this, we have in our architecture, we have this bit taken care of. So we have the data, we've taken care of this part as well. So the next thing is to get the model training and write to MLflow and main IO, so we can leverage that on Streamlit essentially. So at this point, this is probably a checkpoint to see where we are and if everything is working fine as expected. So let's test this out on the Airflow UI to be sure that we're on the right track. All right, so I'm just gonna go back in here and populate this up, and so we are gonna have in our data sales forecast. So we are importing this. Don't worry about this error message, we already added include in here, so we should be okay. All right, so we have this, and I'm just gonna say for file path, so I'm just gonna print that to see how far we've gone on that front. Okay, yeah, so the only thing we need to do just to make sure we call this particular task correctly is at the end of this function, in here where our DAG is, we are going to call this particular function, and we're going to say extract data task. I'm going to have the extract result. Even though there's no result returned for now, I'm just going to call that for now to be able to see that correctly on the UI. So let's go to the Airflow UI and do a refresh. All right, so there's an error in here. So it's saying we have the timestamp. It says Airflow you choose timeout. When we have this, the top level Python code, so it's because we are importing the data, some things in here at the top. Let's see if we can quickly fix that. I suppose it's because we are trying to import, if you look at the timeout error in here, it looks like we are trying to import from here. So it looks like the import is heavy in this case. So what I'm going to do is move this up just below this, the top level. We should that should relieve the task of importing heavy code at that point. So I'm going to refresh this and see if that fixed that. No module name holidays. I'm just gonna have to do a pip install in that case. So that fixed it, but it's saying there's no module called holidays. So let's fix this particular issue. So I'm just gonna try and restart this particular DAG, because when I check my requirement.txt, I can see the holidays in here. So apparently it's not picking that up. So I'm just going to save that and do Astro dev restart. So if I do a restart, it's going to stop the project and start it again from scratch, and hopefully that fixes the issue, because the only suspect that I have right now that is coming to mind as we speak is that each of these particular tasks that I have in this Docker image that I'm building, they are not part of what is being packaged when the Airflow is starting. So it looks like the container needs to be rebuilt, and everything needs to start again. So let's do that. Okay, the project is starting up, and we can check this now while it's still starting up. So let's check in here. So if you check API server and let's check the logs, you probably will see that it's starting up. So it's done, and everything seems to be okay. So let's check again and do a restart in here. Okay, so the error is still persisting. We need to find a way to find a permanent fix for that. Apparently that restart did not fix it, so what I'm going to do is do Astro dev kill just to kill all the whatever project is currently running. I'll kill all of them and then restart the project from scratch. So what I'm thinking is it just restarted the app. It didn't really do anything to the images or something. So I'm going to just delete all of them, all the images that have been created, and there's no volume right now, so that should be kind of straightforward. So I'm just going to have Astro dev start to start the project again from scratch and rebuild everything from scratch. And I believe that should fix it end to end, and there should not be any issue afterwards. Just waiting for this to start. So it says you couldn't find this particular network. Yeah, so in case you run into this issue, just first thing to do is to rename this. I'm just going to rename that for now, and then start the project. So you can start with the base image, and you'll see that once it starts, it's the same name. So all you just have to do is rename this override again, and that will fix whatever issues you have. Yeah, so once that comes up, I'm just going to rerun this command again so you can do the extension, because right now you only see Airflow without those extensions. So to get the extensions in place, you just need to start it again after you rename the override YAML file. It should be fairly straightforward and fast, so we don't have to wait a lot. So you can see it's starting now. We have MLflow DB, the main IO as well, all coming up correctly. So it's almost done. So no DAGs yet. The reason why it is not starting up is simply because when I had my why the DAG is not importing is in my sales forecast training. When I called the function, I didn't call this particular outer function, which is the DAG. I didn't call that. I don't know how I missed that, but I need to just call this particular guy, and that should fix the issue in here. So when I call the function in here, that was fine, but I need to call the DAG so you can register the DAG as well. And essentially this is not required. We are not having any cross DAG implementation in this case, so that's not required. So in here I have the extract task. So let's try and trigger this and see if everything is working fine, and all the data is coming through. So if I click on this as before, you see that it's generating the sales data, and yeah, that should be fine. Apparently the number of days that I put in here is a long one. I'm just gonna reduce it at least for now. So I'm just gonna put it as just up until March 31. All right, I'll let this run to completion, but it looks like it's gonna take some time, so I'm just gonna fail this and to mark it as successful. So I'm just gonna mark it as successful. That is fine. Yeah, that's successful. I'm just gonna retrigger it again. So in a case where you want to reparse it, so you don't have to like refresh the page or something, just do a reparse DAG, and that should to fix it. So this should generate from just January to March, so at least for our testing purposes in this case. So you see that we generated data for 60 days. So we say sales file is 60, the output directory is here, we generated all this information, so we're good to go. So nothing was returned, so that was good. So we had all the data as expected. So now we can essentially continue the implementation. So we have the extract task in place. Now let's get the validation and training the model as well. So let's do that. So if you go to this, if you go in here to the, so I have my, where is it? Yeah, I have my extract task in here. So I'm just gonna have, let's see, what else do I have in extract task? Yeah, so I generated the files. I just need to return. So once this file path is generated, I can say my total files is gonna be the sum of length of path, length of file path inside of paths for paths in file path of value, then generates this. I don't necessarily have to do this, but yeah, I mean, it's something I can just for data type and the path in path.items, so I can print yeah, data type, the length of path as well. Maybe let's put this as length of path, yeah, and call this, close this up and call this files, yeah. Then I can return this JSON object. So this will be written to XCOM. My file path is there, and the total files is this. Total files is that. Good. So that will be done for. We are now done with the extract data task. So let's get in our validation task. So in our case, we have a task in here. So we have dev validate data task. So we're going to put extract result data, which is the data that is exported from the previous task into this particular function. So we need to first extract all the file paths in here. We don't need the total file path, so that's not really required. So what we need to do is just to have, let's get quickly total rows. It's going to be 0. The issues found, if there's any issue, it's going to be this, yeah. And then we could just put in the login logger.info, and we call this validating. Let's get logger in place. Just at the top in here, we can say import login, and then we can have a logger somewhere here, yeah. So we can use our logger. I want to start to enforce the logger instead of prints, yeah. So I'm validating length of file path sales files. Essentially, that's what I'm trying to do in here. Okay. Now, for I, which is the enumeration of the files inside of sales, I'm going to have for our sales file in enumerate file path sales, and let's extract just the first 10 records and ensure that we are able to do that, because it might be difficult to validate the 1000 plus the records that we generated. So I'm going to have pd.read_package for the sales file. So if I equals to 0, which is the first one, let's quickly if I equals to 0, yeah. So I'm gonna have logger. So the sample sales data column, I need the column to be printed in here, so I'm just gonna say sales data columns. It's gonna be df columns dot to list, yeah. Standard pandas, yeah. So if df.empty, so there's nothing inside of it, then the issues found, it's going to be sales files is empty, then continue, yeah. Otherwise, we're going to have a couple of required columns in here. It's going to be, I'm going to have date, store ID. I'm going to have product ID, quantity sold, then the revenue is going to come in place, revenue, And yeah, that will be all. I don't need the cost for now. So those are the required columns in this case. So if there's any missing columns, I'm gonna say the set of required columns minus the set of df columns. Yeah, so that will give me my missing columns. So if there's any missing columns, I'm just going to have missing columns in there. Otherwise, I'm going to have the total rows is going to be the length of data frame, length of df. Yeah. So if df quantity sold, let's add additional validation in this case. Quantity sold, let's start with the minimum is less than 0. Then there's a problem. You can't have negative quantity sold. Yeah, it's always going to be plus. Then if the revenue, if df revenue, the minimum dot mean is less than 0, you have negative revenues. That is also wrong. Now the next thing we want to do is just validate some of the data type and then write the validation summary. Essentially, that's all we need to do in that case. Well, if you want more robust validation, you can write them. So I'm just going to quickly add the data type in here. For data type in file paths and file path, what am I doing for data type in promotions, customer traffic, and store events, isn't it? Store events, which is what we had in our, just gonna close this. In here we have promotions, yeah, promotions, store events. Let's see, we had it in here, everything is inside. So yeah, we have file store in our file paths in here. I think why did I do this? Yeah, I think this is probably in here. We have 3 record that we put inside of file paths, which is, where's our file paths? Yeah, so we have the sales, the inventory, and the store events, which is sorry, the promotions. Rather, we can confirm this, but we are only concerned about those 3, right? So you have the promotions, the customer traffic, and the store events in this case. So if you had additional validations that you need to do in there, you can. Yeah, so if the data type is in file paths and the file paths is having that particular data type, essentially, like maybe I should add a comment in here. This is optional, so we're checking for data types. Yeah, so in here I'm going to have my sample file is going to be file paths for the first record. So I'm going to have df is going to be pd to read paquet. Once I read the paquet, then I can say print. No, I don't want to use print anymore. That's easily coming to my hand. Just gonna have the data type that we want to use. In this case, it's gonna have the data shape of df.shape, and then the same thing, we have the column, so we have logger.info, we have the data type, the columns is to list. Good. Now let's write the validation summary at the end of the day. So we have validation summary, which is going to be equal to this. Total files validated is going to be length of file paths, sales, and we extracted the first 10 record, isn't it? And then we have the total rows. Total rows is going to be total rows. Then we have issues found. Is that we have the issues in this case is going to be let's get the first 5 issues. Yeah, issues found, and let's extract the first 5 records in there. Then the file paths, I'm just going to add a comma in there. The file paths is going to be file paths, and the reason is because we want to ensure that when we are training the model, the file path that is exported from this validation is what we'll be using to read the data when we get to the training of the model. That is very important in this case. So we have validation summary, all this coming through, and the file paths is also part of the exported data. So I'm just going to say if issues found, then we can say validation summary is that. Then for issue, in issue, we just so at this point we can easily just raise an issue. We can raise an a validation error. Otherwise, else we can just say a validation pass, and that's it. And we just quickly return the validation summary. That's all we need to do at this point. Okay. If you have any questions, I think it's kind of straightforward, but if you have any questions, you probably need to go through the video, or if it's something that you probably require me to clarify or something, you can drop me a comment in the chat, and I'll try as much as possible to make you understand what is going on in this case. So we have a data extraction done, which is the realistic, in this case, sales generator. Once the data is fine, we validate it. Yeah, we extract the data, we validate it. After validation is complete and everything is passing, the next thing is for us to train the model. Now let's do that. All right, so if I go to the in here, after this I'm just gonna have for my I'm gonna have, so I have my extract results. I'm gonna have validation summary. Where am I? Validation summary. It's gonna be this. So I'll just pass in whatever result that I have in here and pass it into this function. This is gonna be strange to probably Airflow 2.0. If you are familiar with that, you see that you probably need to do some dot results, or you use the XCOM TI and extract data from there with XCOM pull and XCOM push. But in this case, just return the function in a task and you're good to go, and you can pass it directly in here. Okay, yeah, so that's the validation summary in place. So the next thing is for us to start the model training. So let's create a new task to do the model training. So I'm just going to minimize this. Let's just collapse this up, collapse this, and collapse this. So we are done with these two. We can train the model now. Task, let's say dev train models task. So we are not training just a single model, we are training multiple model. So we're going to have the validation summary in there. Okay, I'm just going to give it a little bit of space in here. So the first thing we want to do is extract the validation file paths. Yeah, in our case we have file paths. It's going to be extracted straightforward from there. So I usually have a login, and the reason is because it helps you to know which kind of block of code is problematic, if any, at any point in time. All right, so let's get the sales data frame. Okay, it's going to be this. The maximum files in this case is going to be 50, and we don't have to necessarily limit it to 50, but because let's start with 50. If we need to expand the model, we can do that, but for now let's just leave it at that for now. Okay, so if we have this, we just read this in the sales, and for the max file path, so we read the package, then we append the data frame in here, and we say if I equals to 0 after every 10 checkpoints. Yeah, we're gonna have loaded. So we just load, we are loading this, so we say loaded i+1 files. Yeah, yeah, once that is done, we have pd.concat. So we just make sure that we concatenate everything into a single data frame, so we can use that. So we can say print combined sales data shape. It's gonna be this. Yeah, sales. I'm just gonna add a function f in here. I'm gonna have sales df.shape. Yeah, then our daily sales is gonna be here, sales df.group by. Yeah, we group by the date. Let's start with that. So date, we have the store ID, the product ID, and the category. Yeah, product ID. Let's add the category as well. Then we aggregate this, the aggregate. We're trying to aggregate the quantity sold, the revenue, the cost, and stuff like that. So we have the quantity sold. Yeah, we have the revenue, which is the sum, of course. We have the cost and the sum. Yeah, I'm just gonna move that down there. Yeah, add a comma to that. Yeah, add a comma to that. Then we have the profit as a sum. We have the discount percent per percent. Yeah, and this is going to be the main. The unit price. What am I doing? Yeah, that's fine. Yeah, I didn't add a comma to the profit. So in here, I need to have unit price. I need to get the mean of that as well. Yeah, once that is done, as simple as that, we just need to do a reset index. Yeah, so at the end of this aggregation, we just do dot reset index. All right, and I'll call the function, and that should fix that. So it looks like I'm having a syntax issue in here. So I have my sales data group by. I need to close this particular guy, and that's good. We're good to go. Good. Now, essentially, that does the aggregation for me. So I have my sales aggregations as daily sales, so I can see the dates on each day. What store, what product, what category is having all this quantity, all these aggregations in place. So the next thing is to just get my daily sales and rename that the columns in this case. So let's have daily sales. It's gonna, all these are just data cleaning essentially. So I'm renaming daily sales dot rename, and the columns in this case is going to be whenever you see revenue, I'll call this sales. You can call it what you like, but just make sure that you're consistent across board. Now, if the file paths dot get promotions, if there's records, then let's load that promo df. It's going to be pd.readParquet, and then file paths. What are we going to do without pandas? Oh my god. I'm just going to minimize that. Once I have the, what is it called? Yeah, the promotions, I have my promo df, and in my promo summary, let's put this as summary. I'm gonna have promo df group by the date. I don't need the store, I just need the product. Yeah, across board, and I'm gonna extract the discount percent in there and get the max. All right, let's reset the index as well. Reset index, and we should be good to go. Good. That's my promo summary. Now, in this case, promo summary is going to give me has promotions, of course, because promotions is going to be. I just need to quickly add that to that. So whatever I have in this case, once there is I extract the discount percentage. Whatever product that I have in this case for that date, I'm going to add as promotions to that. So we have date, product ID, and as promotions for each day. Makes sense? All right. Now let's join them to make sure that whenever we see a sales, we can concatenate that with the promotions in this case. So I'm going to have daily sales. It's going to be daily sales dot merge. Let's merge that with the promo summary, isn't it? Promo summary, and let's extract the date. Yeah, we extract the product ID, product ID, and as promotions. Why did I use as promotions? It should be as promotion. Yeah, that should be fine. Let me just check that I don't have as promotion. Okay, just 2 records, that's fine. So as promotion is 1, yeah, and then in here I'm gonna join this on the data and product ID, and how is left. So I'm having daily sales on the left, promo summary on the right, and I merge them together. Essentially that's all we need to do. What am I doing wrong in here? So what's this saying? It says promo summary is accessed before, so I just need to tap this up. So my daily sales is fine. All right, so the daily sales is going to be, let's get the as promotion. In this case it's going to be yeah, fill NA as type integer. All right, just to cater for any missing records or something if there is no any. So if there is no promotion on the record, on the sales, on the product, yeah, on that particular day, then we just fill it as 0. Any other ones we have 1. I hope that makes sense. Yeah. So in our daily sales, in here I'm gonna daily sales. Let's get the I don't need to do this anymore. So I just go back in here and says if the file paths dot get the customer traffic, yeah. So our promotions is done. Now let's get in our traffic into this daily sales as well. So I'm gonna have traffic df, traffic dfs is gonna be this. Yep. And I say for traffic file in file path, yeah, let's get the customer traffic, and get the first 10 records. I mean, this is just not it's not exhaustive, but if we want more data, we can increase the number of records. But for now, let's leave it at that, and we can extend as we go along. Okay. So we have let's just do it once in a one-liner. We have traffic dfs dot append pd.read package, so we don't have to have separate variables for that. We need to be as memory efficient as possible. So pd.concat, yeah, let's concatenate all traffic dfs, ignore the index, that's fine. And then let's do aggregation on this. So traffic summary is going to be this. We are going to have traffic df the group by. So in my case, when I concatenate all of them, it's not into traffic dfs, it's into traffic df. Yeah. So I'm grouping this by group by, and I'm gonna have the date and the store ID, and I don't need to extract the customer traffic unlike promotions. I just need to do an aggregation on this. So I'm gonna have customer traffic, and this is why it is important to be as consistent as possible. Otherwise, if you mistakenly had something maybe traffic instead of customer traffic, then you're probably going to have a wrong result. So please be careful of that. So I'm going to have reset index, in this case reset index, and we should be good to go. So that's my traffic summary. Then I can have my daily sales to be merged. We merge that we have the merge traffic summary. I don't need to extract this. I'm just merging on the store ID on the hour is left. That's fine, and that should be okay. All right, so that's my daily sales. Now before we now train, let's print this out and then get our model trainer and all that into the picture. So our data should be clean enough for us to and ready for us to use to train the models. Yeah, so let's just say logger.info. We have final training data shape. It's gonna be this, and then let's print the columns. Logger.info. I don't know why I keep typing print. Yeah, the columns in this case is gonna be daily sales columns.toList. Good. All right, now let's get in our model trainer. So let's train the models. All right, let me see. So we've got, so we don't have to do it inside of this. Yeah, let's move this outside. Yeah, that should be fine. I'm just gonna have my trainer. It's gonna be our model trainer. So let's get in our model trainer, which is gonna be created in the includes directory. So I'm just gonna copy paste that so we can go through the code, and it should be fairly straightforward. So our model trainer is gonna be inside of ML models in our includes. So includes, let's create an ML model directory in here. So apparently I need to restart my PyCharm. Once we've created our model trainer in terms of the train models.py, the next thing is for us to start implementing that. But before we do that, let's quickly aggregate our store sales daily to have a variable in this case that we can use in our trainer. It's going to be very useful as we go along. All right, so I'm going to have store daily sales. It's going to be similar to what we've been doing before. Daily sales dot group by. So we're going to be grouping this by the date and the store ID. All right. Then we aggregate this on sum, and sales is going to be sum. As promotion is not going to be sum, it's going to be mean, because we want to get the mean. In this case, we have the quantity sold, which is going to be sum. Yeah, we have the profit, which is going to be sum as well. We're going to have customer traffic is going to be the first thing in this case for each of the store and the date, and then it's holiday is going to be first. Okay, so this is what we're going to be using, especially when we want to do the training and testing. All right, so once that is done, the next thing is to get the store daily sales and convert that to proper date. Once that is done, the next thing is to split our training data into, I'm just going to minimize that, to split our data set into training and testing data. But let's start implementing the model trainer in this case, so we are on the same page as we go along. All right, so if I go back to the train models, the first thing we want to do is to create a class in this case. So we're going to have a class called model trainer, and in the initialization, I'm going to have the config path, which is going to be a string. Of course, it's going to be in user local airflow config.yaml. Not necessarily airflow, so we need to have an include, because everything will be in include directory. All right, yeah, then we are going to have this inside of config, then ml config, so we know for sure what is going to be saved in there. All right, so once that is done, let's open that up, and I'm going to show you what that look like shortly. We can just safe load this. I'm just going to import this name. Why is it coming from message? But yeah, I'll use the YAML. Yeah, that will be fine. You just have to be careful. If you import from the wrong library, then you're going to have some issues in there. All right, so let's create our config.yaml so we are on the same page. Okay, so I'm just going to touch this. I'm just copy that and then touch this. Okay, we don't have a folder yet, do we? So I'm just going to then touch that. Okay, so inside our ML config, we need to get everything that will be required, like the models. Yeah, so in our models, we're going to have XGBoost, which is going to be of params and estimator 100, max depth of 6. Let's do 6. You can increase the number of trees. The learning rate in this case is going to be 0.1, and the objective is going to be squared error. Usually XGBoost performs well on squared error, but you can change this and play around the objective as you like. All right, then the random state, which is more like a seed in this case, is going to be that. Then we have for light GBM, I'm going to have something similar. Number of estimator is going to be that. Then let's add a number of leaves, in this case leaves. Then the end estimator is going to be 100. We don't need the maximum depth in this case. Learning rate is going to be 0.05. You can play around with this in case you want to change things up. Regression is going to be the objective, and the random state is going to be 42 as well. All right, and that will be all for that. If you want to add profile, you can. I suppose you can have something like this, but in my case, I'm not going to be using profile, so I'm not going to. If you like, you want to do that, you can do. Params, we can add a seasonality in this case, something like that. Then you have something like yearly seasonality. weekly, maybe daily as well, and you can change it to something like true. I don't need this anymore. Yeah, this can be true, and maybe daily, maybe false. Yeah, I mean, it depends on what you want, but this is probably one of the ways you can configure Prophet. Yeah, but that will be left to you to decide. All right, now let's go to the features engineering. I'm just gonna put this as feature engineering. So for the features, I'm just gonna get that in the date feature. Date features is gonna be the day, week, year, month, day of the week. Yeah, that's fine. That's everything I need in there. Then we have the lag features. All right, we have 1, 2, 3. Yeah, instead of 1, 2, 3, I'm gonna have some numbers in here: 7, 14, 21, more like a Fibonacci number. Yeah, 21. Well, not necessarily. I mean, this is something that you just have to look at, but you don't necessarily have to have it in a Fibonacci sequence or something. So my Windows is going to be something similar to that: 3, 7, 14, 21, 30. Then the functions that we'll be using is going to be mean, standard deviation, mean, max, and median. All right, then for data validation, I'm just gonna put that in here, data validation. So I'm gonna be required columns. It's gonna be something like date. So let's get the date in. We have date, we have sales, store ID, maybe we can have product ID as well. So those are the required column across board, and the data types that might be required would be something like date time, store ID, float 64, and product ID. So if your store ID and product ID are stored as maybe string, you might want to change that. Okay, yeah, let's do one more thing in here for the data validation, and we have value ranges. So for sales, I'm gonna have the minimum to be 0, and the maximum number of value in this case is gonna be 1 million. All right, now yeah, let's get a training configuration in place. Training configuration. So I'm gonna have the test size of 0.2. Yeah, my bad. Test size of 0.2, train size, yeah, let's start with that. Let's just validation size 0.1. CV volts is 5. Then the metrics that we'll be using is going to be RMSC, MAE, map, and R2. Yeah, I almost forgot that. R2. Cool. So these are the metrics that we want to base our evaluations on. All right, so as we go along and train the model, we need to get at least these 4 metrics out of the model, so we can properly evaluate the model performance. So we have inference. It's going to be the batch size. It's going to be, let's say, 1000. You can reduce or increase this. Then the prediction length is going to be prediction horizon, not length. So it's going to be 30 days. The confidence interval is going to be, yeah, let's put an interval of range from 0.8 to 0.95. All right, then our monitoring configuration. Then we have the monitoring. So for our drift detection, if there's any drift detection that happens in the model, we can have that as well. Drift detection is enabled. I need to enable this. Yeah, and let's change the window, the method in this case. So there's a method called Kolmogorov-Smirnov. This is probably a great method for determining the drift detection in a model. But yeah, if you have any other approach to determining the drift detection, you can do that. Performance monitoring, in this case, is going to be enabled as well. Then we have the alert threshold. Let's see, RMSC is 1000. MAP is going to be 0.2, R square 0.8, MAE 500. That should be fine, I suppose. But yeah, this is what I'm kind of looking at in terms of my ML configuration. Yeah, so I'm just going to close this up, and with the assumption that this is going to be correctly passed, we can continue. All right, so once I load the model, then inside of my config, the ML config rather, once this is loaded, it's going to be saved inside of config, and then we can have self.model config. It's going to be, yeah, instead of model, it's going to be models. I suppose we can quickly take these models. Yeah, so yeah, self config is going to be the config models. Yeah, not model, it's models. Then we have the self.training config. Let's see. Yeah, then we have self.mlflow manager. It's going to be we need to register a manager in this case, MLflow manager. Yeah, and we need to set the config path. Yeah, so we currently don't have an MLflow manager, so we need to create one. Now let's get our feature engineering in place as well, but before we do that, let's quickly create our MLflow manager. So in our MLflow manager, let me see, I'm trying to see how fast we can go with that. Yeah, so if I have in my utils, I'm going to create a new Python file. I'll call this MLflow utils.py. In my MLflow utils.py, I can create my MLflow manager in there as a class. So I'm going to say MLflow manager, which is going to be like that, and then the config is going to be config path the same. We load that. Yeah, let's see what's going on in here. So it says we load this up and then import the name. So let's import from YAML. MLflow config, yeah, self-tracking URI. We get the MLflow endpoint, which is going to be something we're going to implement shortly. The tracking URI seems to be fine. Experiment name seems to be okay. Yeah, registry seems to be fine, what I'm expecting. MLflow set tracking URI, which is good. I setting that correctly. That'll take some time. Set experiment, we're setting the experiment in this case. If there's an error setting that, fail to set experiment, good. Then if there is an MLflow tracking URI, then let's set it to 5001. The reason is because we by default, when you try to set it in here, maybe something fails, we want to reset the tracking URI correctly. Then we're gonna have the tracking URI, okay, then we need to set these environment variables. So let's go to our environment variables and set those as we go along. So in our Docker file, if you can still recall, this Docker file is what was used to bootstrap this model. So we're gonna have env and set the MLflow tracking URI to be 5001. We need the S3 endpoint URL, which is from the main IO. We have the access key ID, the secret access key rather. Then we have the default region as US is 1. Good. But before that, let's install any additional dependencies for our ML libraries. I'm going to have user of root, and then I'm going to run apt get update, install the yes, and then build essential, the git, yeah, I need that, gcc, g++, and then if everything is successfully installed, I can remove the apt list, so apt list, so it reduces the size of the image that is being created. Now just below this, I need to just choose user Astro, so we can properly set those environment variables. And you can see that I switched to user root, so be able to run this. Afterwards, I switch back to user Astro, so that's very important as well. Good. Now going back in here, so our environment variables should be properly set now. Import OS. So let's get our libraries and dependencies resolved. So import login, then our logger is going to be that. So that should be okay. Okay, I suppose that is something. Now let's get our ML flow in place. We just need to do some imports in here. Import ML flow, and from ML flow we import ML flow .sklearn. We get the sklearn. We get the xgboost as well. Import ML flow .xgboost. We do the same for lightgbm. Import ML flow .lightgbm. Import ML flow Python thing. Yeah, for now let's leave it at that. So if we have any additional imports that we need to do that as well. But as we go along, this should resolve some of these errors that we're seeing in here. Good. Now going back to this, so we say we set the environment variables, which is usually what is set in the Docker file. That will be automatically set. And then if there's any issues, it's going to try to retry with that, which is good. Now the ML flow set experiment is good again. So if it tries to set it by default and it fails, it needs to just retrace itself and then reattach it again. All right. Then once that is done, we set the ML flow. Yeah, we need to implement this get min IO S3 endpoint in this case. All right. Can we do it in here, or should we create a new file? I mean, yeah, let's create a new file. I'm just gonna say include utils service discovery.py. All right. And I think I have one service discovery somewhere, which we can quickly copy paste in here. So I have a simple service discovery. So what I was trying to do in this case was that if you try to get an ML flow endpoint, you read the URI. If that doesn't work, if that is not set, right, you have to go through this. Otherwise, if this environment variable is set, just return it, and that should be fine. Otherwise, if we have any Docker environment that we want to use, we can use that, or we use the core executor, whichever one that we're using in this case. Now, once we have the container data, we have a couple of endpoints that we can test with. We can test with ML flow, Docker internal, by default, the Docker engine bridge, and then the localhost. So each of these will be tried. So to see where the particular service is currently running. So if it tries with ML flow, maybe the name is not reachable for some reason. It tries with this, it tries with this, it tries with this. So if after everything and it's still not able to reach that particular image, then it's going to break down. And the way to do that was just to do like a URL request and check the health of that endpoint. After 2 seconds, if it doesn't receive any response, then that particular endpoint is not available, so you can skip it. So I just do a loop in here to do that. Otherwise, if nothing works, just return the default and just continue. The same thing was done for min IO, and you can see that it's literally the same thing, and I just went through that. Then for the ML flow URI and min IO, so we don't necessarily need this bit. This is just for backward compatibility. I just copy pasted it from one of my project that I was working on. All right, so this should be fine. All right, so that's my service discovery in that case. So I just need to import this from my service discovery endpoint. But to make sure that everything is working as expected, I'm just going to import this. Yeah, but we're not going to be using the fully qualified name because we are inside MLflow util, so it's easy for us to just do from current directory service discovery. I hope that makes sense. Yeah, so we get the main IO endpoint, and then let's get the MLflow endpoint as well. Get MLflow endpoint. Good. All right, now let's continue. Just below that, once we establish a relationship with the what's it called, the main IO endpoint, we set the rest of the environment variables, the access key and the secret key, which is by default, if nothing exists, main IO admin. It's just to set the MLflow client to use this tracking URI. And why is this even important? Yeah, the reason why it is important, if you want to know, or you ask me, is simply because by the time we are running our MLflow experiment, don't forget we're trying to train a model. Yeah, we need a way to be able to track the metrics, the artifacts, and if some records that are generated. In this case, maybe you are logging something and all that. So we need a way to be able to track this as the model is going on, and this is going to allow us to gain insight into what is going on in the model. Not only just logging and printing variable values, but actually maybe logging the artifacts and some metrics and stuff like that. We can easily track those with the tracking URI. So that's why it is very important for us to do this. So we don't necessarily need to do this if the tracking URI is not going to be something that is usable. But yeah, so the tracking URI in this case is something that you want to make sure that is there. All right, now once that is done, the next thing is to implement to continue implementing the rest of the services, isn't it? So we have in our train models, let's go back to train models. Yeah, so the MLflow manager essentially has been implemented. Let's see if we can import that. So I'm just going to import that, and we need to correct the import directory. And so in my MLflow, I need to remove the include, so it's going to be from here. By the way, I just realized that I don't have an init directory in this file, so let's create that. Init.py. I'm just going to paste that in here as well, and that's fine. Okay, so I have my utils, MLflow utils, and MLflow manager. You can ignore these scribbles. It's trying to force me to use it's trying to force me to use the full directory, but I know for sure in here I already have the data in here, so in the utils directory should be fine and kind of straightforward. All right, now our model trainer, we can continue. Our MLflow manager seems to be okay. Now let's get our feature engineering in place. So feature engineer is going to be feature engineer, and then we put in the config path as well. Now let's implement the feature engineer. I'm just going to create a new library in here and call it feature engineering, isn't it? Feature, is that, yeah, engineering, feature engineering, if I can only type that. Yeah, okay, so in my feature engineering pipeline, I'm going to copy paste that because it's kind of long, and we can go through what that entails. So I'm just gonna in here. So what we're trying to do is essentially do the same thing in here. For our feature engineering, we load the library and then get the features and validations in here, which is what we created before in our config. Don't forget, we have our features, yeah, and our config. What's it called? The validation, yeah, which is this features and validations, including the data type and value ranges. So these are the kind of things that we are reading from there. Then we are creating date features, which are the features that we need in here. The lag features, which are everything that we read from the feature config. The rolling features, you can go through this in detail. We have each of them have been implemented in this case, so you can, you know, take your time to go through them in detail. And of course I have a couple of mathematical functions in here, but yeah, so you need to study that. I don't know if I can just add a comment in this case. So it's the cyclical features for, yeah, so we have the month sign, month cosine, day cosine, day of the week sign, and stuff like that. Then we create all the features straightforward in here. We just call those functions and we return the data frame in case there is any missing values. So we handle the missing values in here, select the features in here. I mean, it's kind of straightforward from there onwards, but essentially this is my feature pipeline. So in my feature pipeline, I just try to, as much as possible, get something like the sales velocity, the ratio features, the day of the month, day of the week, the business quotas. A lot of features are here that helps us to essentially get this feature engineering in place. So please take your time to go through that. So yeah, once that is done, in my feature engineering, I can just import that as well. So instead of full include, I just remove the include in this case. So I have my feature engineering, and then the last one will be the data validator. So I'll say self data validator. It's gonna be data validator for the config path. All right. Now in my data validator, I'm going to create what's it called, another library, and I'll call that data validation. Let's create a package in this case. So I'll call this data validation. Yeah, that will be my library name. And inside of data validation, I just create a couple of validators in here. I'll just copy paste that as well. Yeah, so what I essentially do is to validate the schema by looking at the missing columns, the data types, which is standard. Yeah, then data quality, you check the total rows, the column statistics, and if there's any quality issues. We try to do that by checking the null count, the null percentage, the unique values. These are kind of like standard stuff that you want to do, especially when you're building a model, to make sure that whatever you're doing is fine. So if there's any outliers, you can detect them by using the quantile. If it is in Q1, Q2, Q3 and stuff like that, you can do that. And then the Pandera schema, I'm using that to get the value ranges, especially in our case. Then validate the time series to ensure that the date follows a particular sequence. So if you have on a daily basis, there are no gaps, then your model will be fine. Or if there are gaps, then you probably will suffer some maybe hallucination, or you know, the model will just not perform as expected. And that's why it is important to validate some of this information. So something like the time series has to follow a particular sequence. So if it is like on a daily basis, then you can stick to that. If it is like on a weekly basis, you have to stick to the weekly basis. And if it is monthly, yearly, and whatever sequence that you want to follow, you have to follow those particular sequence. So you cannot have on a weekly basis, then you have some data that is coming through as on a daily basis. It's going to mess up the behavior of the model. So you need to have a time series that is properly validated. Then the prediction data will be using this to check the mean standard deviation, and if there is any distribution shift that is very significant, more like the so you can think of this as a flat line. Yeah, if there's any spike within that pipeline that is up to 3 times whatever the training standard deviation is, then it's going to signal a distribution shift in this case. And at the end of the day, I generate a validation report, and then if there's any schema validation error, data quality error, time series errors, and whatever, I just generate that, and we just play along with it. Yeah, so yeah, take your time to go through that, and it's going to be kind of straightforward if you just read it through. All right, so I've just import my data validator and remove this include from there. Yeah, So that should be all that is required in terms of the libraries that are going to be imported. We're still going to create a couple more, but for now let's continue. So I'm going to have self.models. So in my models it's going to be here. So I'm going to have 3 models, of course, but for now let's continue. Self.scalars is going to be for scaling to avoid weight imbalance. Then we have encoders. It's going to be this. All right, so that's my initialization function. So let's prepare the data. Prepare data. Okay, and I'm going to have this pd.data frame. Then I'm going to get the target column in this case as a string. So the target column is going to be sales by default. All right, then let's break this down. So we have the date column. It's going to be date, of course. The group column is going to be optional if in case we need anything, but if we don't have that in place, that should be fine. That will be from typing. Thank you. Let's import our pd as well from pandas. Yeah, so that's our date column. Then the categorical columns are going to be listed in here as well, and easily we can just return a tuple of data frame. Essentially we don't have to like specify this, but let me just remove this for now. Yeah, let's prepare the data. So essentially we have logger.info. We are preparing the data for training. We don't have logger in place, so import login and our logger, of course. All right, so that's our logger. Let's get our required column. Required columns is going to be date, of course. Then the target column is going to be part of that. Now if there is a group column, then we should be able to validate those alongside with the required columns. So we just extend it to include the group columns. Now if there's any missing columns, in this case we're going to have a set of required columns minus set of df.columns. So if the required columns consist of five columns, and at the end of the day our df columns consist of only 3, we have 2 more that will be subtracted in here, so we get a missing columns. So if there's any missing columns, I'm just gonna say missing required columns for the training. All right, we just raise the errors and not continue, because it's very important that we have all the required columns that will be necessary for our model training. Now for our df features, we're going to have feature engineering to create all the features. So I'm going to create all features. All right, then I'm going to have the data frame, the target column, the dates column, yeah, the group columns, and the categorical columns. Yeah, and I'll just break this down a little bit. So that would be our df. If you can still recall, in here we have our feature. In our feature pipeline we have the data frame, the target, the dates, the group column, the categorical columns. So yeah, again, that's kind of just calling that function that have been implemented. Yeah, once that is done, we sort this we split the data and sort it. Let me just write it down. So I'll say split the data in a chronologically for the time series. Yeah, and the reason is because we want to make sure that the data is properly sorted in terms of the dates. So if there's any dates that are not in order, or is just like messed up somehow, we want to sort the dates so they are all correctly represented by the date column. Okay, so we sort the data frame. Now let's split it into the training and validation. Yeah, so I'm going to have the train size. It's going to be the length of data frame, length of df.sorted, multiply by, let's add the 1 minus in here, the size of the training config test size. All right, then that's my, what is it, self training size, yeah, which is my test size. So instead of the training size, I'm gonna have the test size, yeah, minus self.training, the validation size, not val size, validation size, yeah. If you check our ML config, you see that in our training we have test size and we have validation size. So we have 30% of the data that is going through for these two. Then the 70% of the data will be used for the training. All right, so that's my train size. So that's why I said in here I have 100% minus this, which is the 10%, and the validation size is 20%. Is it? Yeah, the other way around. Test size is 20%, validation is 10%. Okay. All right, and that will be my figure in that case. Now for my validation size, which is the val size, it's going to be the length of data frame sorted multiplied by the validation size. Okay, now my train df sorted, yeah, I don't know, this GitHub model is not as effective as you probably would have thought. A lot of changes is required to make sure that the suggestions are fine. So the df sorted, I'm extracting up until the train size, which is the 70%. So validation df, val df, is going to be the sorted from 70 to validation size. All right, the test df is going to be from everything else. In this case, train size plus validation size. All right, from there going forward, so whatever I have in my train size plus validation size, the rest will be used for my test. In my case, 70 20 10, yeah. And you can switch this around, you know, by saying if you want to use test and validation 15-15, you can do that, but I'm using 20% test and validation 10%. Yeah, I know when I was talking about this in the architecture, I mentioned that I'll be using 15-15. I just realized that might have changed. So in this case, it was originally 15-15, but I changed that to 20 and 10. But you can leave it at that if you prefer. So if there's any rows with NaN, I'm gonna clean those up, and I'll say train df is gonna be train df.drop na. Yeah, I'm just dropping it, and the subset is gonna be the target column. Simple. The validation df will be done, the test df will be done. So we are sure there are no rows with na in the target column. Essentially, that's what we're trying to do. And I can just say logger.info. The train data shape is I'll just train data split. It's gonna be length of validation. Yeah, that's my training df, validation split, and then test data split. Good. All right, now let's return the three. Train, test, and validation will be returned. So in the order, it's very important. It doesn't matter. I mean, it's something you can handle essentially. So I have my train df, the validation, and the test df. So please ensure that when you are destructuring this, you destructure in the right order as well. Okay, now that's my preparation. So I can have my pre-process features, and I'm gonna have my train df as a data frame, the validation df in there, the test df in there. Now we need to get the target column as well. Target column, it's not sales, it's gonna be sales essentially, but I'm not add coding in that in there. So I'm gonna have exclude column. So let's put this as a list. Yeah, a list of string, and it's gonna be by default date. I'll close this up, yeah, and that should be fine, isn't it? Why is this complaining? It says, yeah, that's fine. Because it's mutable, it doesn't matter if it is mutable or not. What matters is that the data is correct. So our feature columns is going to be the columns that we extract from the train data frame. So I'm just going to say for column in traindf.columns, yeah, if column is not in exclude columns. Yeah, I hope that makes sense. Yeah, and we don't need the target column as well, so let's add the target column into the picture. So whatever columns we have in the training data frame that does not include the target column and the exclusions that we're going to be adding, then those are our feature columns. All right, so our X train, we're almost there. It's going to be train df. Let's do a copy in here. Okay, then X value is going to be val df, then copy that as well. Then our X test is going to be test df feature columns, and let's copy that as well. Good. Now our Y train, which is our result, Y train, the same thing, value and the tests. Now before we return the values, let's encode these categorical values with something like a label encoder. In some cases you want to use something like one-hot encoder, but in my case, because most of them are categorical variables, I'll be using the label encoder to do the encoding in this case. So I code the categorical variables, and I'm going to have let's extract the categorical columns. First we have xtrain dot select types that are objects. So this will be our categorical columns. So we just say loop through this for column in categorical columns. If the column is not in self encoders, let's see, where's our self encoder? I'm gonna say self.encoders. For the column, it's going to be label encoder. Yeah. Now our X train dot location, let's do that, everything in here up until the column. We do a fit and transform of that. So we have the encoders column, fit transform, X train column. Yeah, that's fine. I think we need to do the same. Otherwise, if the else in this case, we just do X train the location, encoders transform. Yeah, that should be fine, I suppose, because essentially it's kind of the same thing that we're trying to do, but the only difference is we are fit transform in this case and we are doing transform in here. So that's the only major the only difference that exists between both of them. So in my X value, I'm gonna have the location as this, and then the X test is gonna be that. Let me see. X test encoding is the same. We're using transform for those. Yeah, that should be fine. Now I'll just do the scaling, handle the scaling as well, in case there's any numerical figures that needs to be properly scaled. So we have our scaler, which is going to be the standard scaler as expected, which is you probably would have guessed that. So I'm going to have my X train scaled. It's going to be the same. We are doing a fit transform for that in the proper scaling, of course. Yeah. Then before we return this, so once we do the scaling, let's do the same thing for so we need to convert this back to, once we finish scaling, we need to convert this back to the data frame so we can preserve the feature names. Yeah, so essentially we just override that. Xtrain scaled, Xtrain scaled, it's going to be pd.dataframe, and then we have the columns is going to be the feature columns, isn't it? Feature columns, and the index in this case would be xtrain.index. We do the same for value, feature columns, yeah, and then xvalue.index. We did the same for the test. Let's go, yeah, that's fine. Now just before returning, I'll just say self.scalars, scalars standard is going to be the scalar, and self.feature columns, just to be able to report that correctly. And I have the xtrain scaled, xvalue scaled, xtest scaled, ytrain, yvalue, and ytest. Good. Essentially, yeah, that's a pre-processing pipeline. All right. Now let's get in our train all model. Okay, so I'm just gonna have train all models. In my case, I'm gonna have the train df as a data frame. We have the validation df, test df. Let me see, where is it? Yeah, so we have okay, so let's see if we are going to change all of them or just use the same thing. So the train df is going to be the pd.data frame, which is good. Validation df is fine. We need a test df, yeah, test df will be required, which is a data frame. The target column is going to be sales. We need to use up to now, isn't it? For hyperparameter optimization, so it's gonna be true by default, and we're just gonna leave it at that. All right, now let's get in our results. It's gonna be this. Now we can start the MLflow run, which is essentially why we intentionally want to use MLflow run in the first place. So whatever training we are doing is going to be inside of the MLflow run. So self.mlflow manager.start run. Yeah, so when I start running, the run name in my case is going to be because we don't want to keep overwriting the same name, so I'm just going to use sales forecasting. I'm just going to call this, yeah, sales forecasting training, yeah, and add a date time to that. So date time.now, the strf time, so that will be year, month, and day, and the hour, millisecond. So I don't need to add a dash between them. Underscore hours, minutes, and seconds. Let's import the name. All right, so that's my run name, comma. Now once the run name is there, then let's tag it. So the tag is going to be model type of ensemble, by default, ensemble, and I'm using use up to now. It's going to be use up to now, which is going to be str use up to now. Good. All right, that seems to be fine, and the reason why I'm wrapping this is because during JSON serialization, you might run into issues if it is not a string. All right, now I don't suppose this is a run ID, not run in. Yeah, so I suppose I'm just gonna replace all of this. They don't seem to be as useful as you would have expected. Try and let's add an except condition in here. Except exception as E. So let's get that in here. So we have our X string, of course, the X value, validation, X test. I know you get what I mean. Y train, Y value, Y test. Okay. Now our self-processing features is going to be train df, val df, test df, and the target column is going to be target column. Okay, good. That is correct. Now let's log all the statistics before we continue. All right. I'm just gonna have my ML flow manager in this case to log the params as my model config, but that's not what I want. So the log params is going to be the train size, the length of data frame, the validation size, the test size, as well as the number of features that is being used. And this is going to help us visualize what is going on as we train the model, each of the models in the ML flow manager. All right, let's start with the XGBoost. Now train the XGBoost model. So we're going to have let's have train XGBoost, isn't it? So we have XGB model. Yeah, that's wrong. So it's going to be self.train XGBoost. I don't think we have the function yet, so we need to implement that. Xtrain, xValue, yeah, let me say xtrain, ytrain, xValue, yValue, and let's use the optional, yeah, so we can do the hyperparameter optimization. And once we do the model, we have the model. We don't have this function right now. We're going to create it shortly. Once we have the model, we do the prediction, xgb.prediction, and we have xgb model.predict, which is kind of like this is standard xgb metrics. It's going to be extracted from there, and we calculate that. So self.calculate metrics. I don't suppose we have this as well, the y test and the y xgb prediction. So essentially we're trying to compare the performance and extract the metrics, and from there once you do the prediction against the test, we compare that against that. All right, so in my what's it called, where is it train XGBoost, isn't it? So I'm gonna have train XGBoost. So let's implement that feature. So I have training XGBoost model. Okay, so we are going to have use up to now, of course. So I'm going to say if use up to now, then let's define the objective. Yeah, so the objective for this particular trial is going to be params and estimators. Let's see. Yeah, I'm just going to copy that from my notes. So the params that we'll be using is a little bit different from what we currently have in here. So I mean, it's something that you can play around with, but I already have something in my notes, so I'm just using that as my param base. Yeah, so some of these will be changing as well. So we have params, and I'm going to add early stopping rounds. It's going to be first 50. So if after 50 you try and you probably see the best parameters to use to get the right result, use those, otherwise continue. But early stopping rounds in my case will be 50. So I'm going to have my model. It's going to be XGB regressor. For this XGB, we need to import this particular variable. So I'm just going to say import XGBoost as XGB. Let's import the light GBM as well. Light GBM as LGB. And then if you want to use Prophet, you can import Prophet as well. I'm going to import up to now to make that that cycle complete. Yeah. So going back to my train XGBoost, okay, so I have XGBoost.xgb regressor, and I'm extracting all the parameters from there. Then I can just do model.fit and get my xtrain, the ytrain, yeah. Then evaluation set is going to be the, yeah, I don't need it to be verbose, yeah, exactly. And then the y prediction, I'll just close this up, and then my y predicate is going to be the model.predict for the x value, and I can return np.sqrt, the mean square error. So I don't need the mean, I need the mean squared error for between the y value and the y prediction. All right, and I just import this name from NumPy. Okay, now as our objective is in place, now let's create a study using Optima, and we are trying to do the direction is going to be as minimal as possible. The sampler in this case would be the, of course, the 42 sampler that we're using, and the pruner in this case would be the median pruner. And this is how you can do hyperparameter optimization. Essentially, that's what we're trying to do in here. So I'm just going to do study.optimize. The number of trials that we want to use is going to be coming from our self.config and the training, and I can say .get optional trials, and if that doesn't work, let's use 50. Yeah, but this is using 100. I suppose we can use 100 too, but let's leave it as 50. So the best parameters is going to be the study best parameters, and these are the parameters that I found. Okay, now timeout. Just hold on, let me explain what is going on in here. So by the time we are training this model, we're using this optional to create a study across all the 50 rounds. We said we wanted to do 50 rounds. Yeah, so each time we are using the learning rate, the hyperparameters for that, and then the value, the predictions, and stuff like that. Each of these data that we're doing across each of these models that we're creating, we are creating a study. So across these 50 data sets and each rounds of training that you are doing, which of the parameters gives you the best result? Yeah, Optima allows us to get the parameters that is best. So essentially that's what we're trying to do in here, and that was why I was trying to log the best parameters in here. So once this is done, these best parameters will now be used, yeah, to actually create a regressor if you are using something like XGBoost and all that. And for light GBM, we can create a separate model, but the best parameter is extracted using Optuna in this case, and this is probably one of the best way to do hyperparameter optimization, because you don't know exactly what happens. So you want to keep switching your learning rate as you go along, maybe from 0.01 to 0.05 or 0.1. You want to keep switching, then at some point you're going to have the curve moving like this, and then it's going to flatten. So at the point where it flattens up at the top, that's where your best parameter will be. But I suppose that's something that is kind of like common sense when you're trying to do hyperparameter optimization. So yeah, let's stick to that, and let's continue our implementation. All right, so yeah, so we have the best parameters in here that is found. Let's see. Then our XGBoost, of course, is going to be based on that regressor, and I'm going to fix that, and the evaluation set is going to be that verbose is true. Now let's just say self.models for my XGBoost is that, and then return the model. Yeah, that's all. Now let's train. Okay, let's train our light GBM, so we don't have to come back to this much later, but before that, let's see, what do we have in here? We just trained the XGBoost. Yeah, we calculate the metrics, so let's implement the calculate metrics before we implement the what's it called, the light GBM. So just above this train XGBoost, I'm gonna have a function in here. Well, it doesn't have to be before that, but I mean, it's something that this is just like, for me, more like second nature. So my metrics in this case would be the RMSC. I'm going to be getting the mean squared error and doing the square root of that. That's the root mean square error. The MAE is the mean absolute error, so I'm just going to use the mean absolute error from sklearn, and y true, that's fine. Then the map, whatever you call it, MAP. Yeah, it's going to be the mean. Yeah, the mean, mp.mean, and the absolute value, which is the subtraction of y true minus y prediction divided by y true. More like the standard deviation, but you get the point. Yeah, and the r square in this case is going to be the r2 score. I suppose we can use it from MLflow or sklearn, but but I think let's see what's going on in here. Where are we using? Yeah, so we're using the mean absolute error and stuff like that from sklearn, so it's best we use the R2 score from there. Let's see R2 score. Yeah, I mean, the reason why I want to avoid using multiple libraries for different things is to make sure that if there's any issue, we don't run into unnecessary complications due to library compatibility. The implementation might actually be the same, but the parameters they're expecting and stuff like that might be different, and the way they calculate it might be different. So it's best to just stick to a single library. So if you're using sklearn data, which is the APIs from sklearn, then you stick to that. And if you want to use the MLflow ones, you stick to it. So don't mix those two up, unless you are entirely sure that the implementation of each of these functions are exactly the same. Yeah, that would be my advice. I learned that the hard way. Okay. Yeah, so I calculated the metrics. All right. So we have the XGB metrics calculated. In this case, I think at this point it only makes sense to log it. Yeah, once we have the metrics, let's quickly log it. MLflow manager, log the XGB metrics, and we're going to be logging these metrics. And instead of logging it directly, I'm just going to have my XG boost, and I'll put this as K. All right, in my metrics items. So I want to log them separately, so I'm prefix it with XG boost, and the reason is because the metrics is going to be the same across board. If you can recall, we have RMSE, map, and stuff like that. So I want to be sure, I want to properly tag this as SG boost, light GBM, maybe prophet, and whatever it is, and that's why I'm doing this loop in this case through the lambda. All right. Once that is done, this can be done on a straight line, so I don't have to take unnecessary space for that. Okay, so that's my log, and I can say self.mlflow manager, and I can log the model as well. So XGB model as SG boost. Then the input example is going to be xtrain.ilog, and extract that from there. Okay, I suppose that should be fine. Let me see, SG boost, let me log model. So I have, yeah, model.json, the run ID, yeah, that's it from Databricks. So in my MLflow wheel model, I have, yeah, that should be fine. SG boost and input example, that's fine. Okay, now let's now log the feature importances. So the features in this case, so feature importance, it's going to be pd.dataframe. Yeah, and let's extract that data frame. It's going to be feature, our feature columns. Then the importance is going to be the SGB feature importances. All right, good. Then I can say sort values as based on the importance. The ascending is false, and so it's going to give us the most important features that is being considered while training this SG boost model. Yeah, let's log that. Logger.info. We have top XG boost feature, SG boost feature. Okay, yeah, we don't need the add. I think we just need to do .toString. That should be fine. Yeah, I just do self.mlflow manager. We don't need to end it for now. MLflow manager dot log params. So I'll just log that as well. So I say XGB top feature I, isn't it? F, and I extract that from the row, which is going to be that for I row in the head. So instead of getting the head for the first 10 records, I'll just do feature importance to iter rows, so I get all of the feature importance. I suppose that can work. I'm just gonna put this as because it's gonna return a value before that as a tuple, so I'm just gonna do an enumerate. Yeah, that should be fine. Let me see. So I enumerated this and it returns the index and these 2 records. So I don't need this, I don't need the row. Yeah, that's fine. Finally, I can say my results for SG Boost is going to be the model, it's going to be SGB model, the metrics, then the predictions. It's going to be predictions, it's going to be that. That's fine. And we're done with the XG Boost. Yeah. We're literally doing the same thing for Light GBM. So I wouldn't necessarily go into the details of the Light GBM again. So what I'm going to do is copy that from my notes and then paste it in here. All right. Let's quickly walk through the implementation. So we finished the XG Boost in here. So for our Light GBM, I'll just implement the function in here. So let's go through that, and I'll talk through the rest of the implementation. So I'm just going to copy that from my notes. So my Light GBM is here. So what we're doing essentially is to have the train, the Y train, the X value, the Y value, the use up tuner as our input in this case. So most likely the use up tuner is going to be true because we want to optimize our hyperparameters. So all right, so we have the number of leaves, the number of learning rate, the learning rate in this case, which is going to be from 0.1 to 0.3, and we're logging that as we're using logarithm in this case to ensure that it is flattening as much as possible. We have the number of estimators between 50 and 300, the minimum child sample, the subsamples, and you can see the metrics that are being used in there. Now for our model, we're using the LGBM regressor. Before now we were using the XGB regressor, which is essentially, that was why I said essentially is the same thing. The only difference is just we're using LGBM regressor. Yeah, that's it. We train the model, then we return it. And in my train all model for my Light GBM, once I train it, I do the same thing, predict, calculate the metrics, then log it. Then the feature importance in this case will be that and then we have the log, yeah, the top Light GBM, and Light GBM is in place. I suppose that's all. In my case, if you want to implement the the prophet, I suppose this is where we're going to be implementing the prophet. I'll take some time to go through the implementation of prophet, maybe in a separate video, but this is where prophet will be added much later, but I'm not going to be going into the details of that. So now that we have at this point we have the XGB, which is the XG Boost model. We have the XGB model, we have the Light GBM model. Now it only makes sense because they are going to be doing most likely the same thing to create an ensemble that I was talking about the other time. Now for ensemble to work fine and to be as effective as possible, what you want to do is make sure that individual contributions of the models are calculated. So out of 100%, what is the contribution of Light GBM and the contribution of XG Boost? This will give you a sense of, by the time we're contributing to the ensemble and making inference based on this model that is generated, we are knowing exactly who to blame. Maybe not who to blame, but we are leveraging the strengths of each individual models. And yeah, essentially that's the major reason why we do that. And you can of course search on Google what the difference, why use ensemble model, especially if you have something like XGBoost and LightGBM at the same time. So yeah, I'll let you do that as an assignment and take your time to go through it. All right. Yeah, so let's do the calculation of individual model performance and what their contribution is, especially in terms of the R2 square contribution. So what I'm going to do is I'm going to do a weighted ensemble based on individual performances. Yeah, individual model performances. Yeah, so that's what we're trying to do. So our XGBoost value prediction is going to give us the XGB model where we did the prediction. We did the LightGBM value prediction as well. Then let's get the R2 score for XGB and LightGBM. So XGB value prediction, sorry, R2 square, isn't it? So we get the R2 score for the XGB. We do the same for LightGBM. So LGB val R2 score. Yeah. So based on this, we're gonna have the contribution. We're gonna calculate the contribution now. But what we want to do is we don't want to completely ignore a poorly performance model. So let's say, for example, our XGB is very performant and is taking, let's say, 80% or 90% of the contribution. LightGBM is performing poorly. We still don't want to exclude this essentially from our ensemble model, and that is why it is going to be important to set a minimum average that the contribution can take over. So if XGBM is performing at 90%, for example, we can set our minimum threshold to say 20%. So whatever contribution you bring, once it is above 80%, cut it off at 80 and give LightGBM 20%. I hope that makes sense. So essentially that's what we're trying to do in this case. But not necessarily you can let XGBoost overshadow LightGBM completely, but in your ensemble model is not going to be leveraging as much as or see like other perspective if you put it like that. Yeah, so that's the reason why we're trying to do the computation in this case, to ensure that the model, the ensemble model, is properly not ignoring totally the poorly performant model. All right, okay, so now we have the R2 score as well. So let's get the minimum weight. Minimum weight in this case is going to be 0.2, 20% like I mentioned. So we get the XGB weight, and we get the maximum of the minimum weight between the minimum weight, which is 0.2, and XGB value over this, which is essentially the percentage contribution of XGB. That's what we're trying to calculate in here. We do the same for LightGB, LGB weight, yeah, which is essentially the same thing for the R2 score as well. Now in this case, the total weight is going to be the XGB weight plus LightGB weight. Yeah, so what is the contribution of XGB weight XGB weight over total weight, and then the LightGBM? So we get that, and then we can just log that, logger.info. We say for XGB weight, let me just make this ensemble weight is going to be this. So we have the weights of XGB and LightGB. All right, I suppose we can use the 3 decimal place for that, so we can see the actual in this case. Then ensemble weights is going to be this: XGBoost and LightGBM, which is what we're going to be using essentially. So we just say ensemble prediction, ensemble prediction. It's going to be that. So we have XGB weight multiplied by XGB prediction plus LightGB weight multiplied by LightGBM. So this is essentially what we're doing at this point, is to do use a simple weighted ensemble based on the validation performance. Yeah, and all of this is generally based on the R2 score. Okay, all right, now let's go back one step. All right, we have our ensemble prediction. We know what the performance is across each of them. We can now create our ensemble model, create ensemble model object based on this. So we have ensemble models. It's gonna models. If I can only type models. So I have XGBoost, and then we have light GBM. Yeah. Okay. In our case, ensemble is going to be ensemble models. It's going to be ensemble model, and we can put in the ensemble models and the ensemble weights. So let's get this into the picture. So we need to create a class for this ensemble model. So in my ML models, where is it? I'll create an ensemble model in here and call this ensemble model. Yeah, once I create that, I can just copy that from my notes. So what we're trying to do essentially is to combine the predictions from multiple models. So essentially we have the weight, which is the initialization. We have the weight for the model. So we get the contribution, we have the equal weights for all the models. So then we normalize that if we don't have the weights. Then in this case, we just get the weight keys and assign them to each of the models that we'll be using in the ensemble. So for the prediction, we just do like a loop. So each of this loop will be like a prediction. So then we compare the results and then compute the weighted average, get the parameters, set the parameters. Then here we are saving it and exporting that, and we load it using this repre is going to be this, as simple as that. All right, okay, so let's import this. Just at the top, we're not using include, don't forget. So yeah, we remove this include, and let's move this to the rest, so we have all of them on the same page. Good. Okay, we're almost done, especially with this ensemble stuff. Yeah, so let me just scroll down into my train models. I'll scroll down. Yeah, so once I have my ensemble model, where is it? We have ensemble models. Yeah, I'm just gonna say self.models. Let's get the ensemble into the picture as well. So extract the metrics. So ensemble metrics. I'm going to calculate the metrics using the Y test and the ensemble predictions. All right, and based on that, as can say MLflow manager .log metrics. Yeah, and I can log the ensemble based on that. Yeah, what's going on in here? So we are saying we're logging the metrics based on this. I'm gonna put this like that. Yeah, that should fix it. Okay, now let's log the model. That should be okay. And then the results for the ensemble is going to be the model is this, the metric is that, and then the predictions are that. Okay, cool. Now this section is entirely optional, but I'll be adding this to make sure that in case you want to use similar code in production, you can, but it's not necessarily something that is required. This is just like a diagnostic model performance to see what the recommendation is and all that. And I probably would just skip that for now. But yeah, let's just see how far we can go. Save artifacts. Okay. Then the current run ID. I think I just missed a step, and I'll just say mlflow.activeRunInfo.id. Just before saving the artifact, I think we need to just generate visualization, more like charts. Yeah, so I'm just going to say we have the implementation already, so don't worry. Do we? Let's say generate visualizations. Yeah, so in our case, let's say logout.info generating visualization for model comparison. Yeah, I'll just quickly do a try catching here, self.generate and log visualization. All right, and that will be my results. The test, let's put it here, test df, the target column. Yeah, I start, put it on a straight line, and we should have an except in here, exception as e, exception as, let's call this this error. Yeah, could use e as well, that should be fine. Just log out of error during visualization, and we're good to go. Now the save artifact should be fine. Generate the run ID. Now we have two functions that we haven't implemented. Let's quickly implement them. So for our visualization, I have the code in my notes. I'll just quickly copy paste that. Where is it? Yeah, just below this. I'm just gonna say dev, yeah, generate that, and that should fix it. Let me see, what is it complaining about? It says the model trainer, isn't it? Yeah, that should be fine, I suppose. Maybe I'll just move this before. Oh, it should be in the same class, isn't it? I was in the wrong section. Yeah, this should be in the same level. Let me see, I'll just minimize this. Yeah, they're in the same level now. Yeah, that should be fine. So let's import the name from typing. Yeah, essentially what we're trying to do is model visualization, so we need to create that in the ML models. So in my ML models, I need to just copy that in my model visualization. I'll walk you through the code so we don't miss out on anything. So what we're doing essentially is to create a class. In this class, we are going to create this, and the style is going to be the Seaborn dark grid. So we use the PLT, which is of course coming from Plotly. Then the colors of the ensemble and light GBM. I even added prophets in here, but you'll see the implementation after this video. We create a matrix comparison to just compare the RMSE, the MAE, the MAP, and the R2 score across all the models. So then we do the comparison essentially. Then we save it. Now the prediction, this is for the metrics, this is for the prediction, similar stuff. Then we do the residual analysis. Yeah, it's a lot of code in here. Then we have feature importance charts just to like rank them and print the bar chart for the feature importance. Then the error distribution charts will be there as well. Then for the comprehensive reports, this is more like bringing everything together at the same time. Then the summary figure should be okay, and I think the model comparison chart should be the last one. Yeah, so that's essentially what we did in here. So you can take a look at that and we should be good to go. Okay, so let's go back to our train all models. So once we generate the visualization, we want to make sure that we synchronize the, we want to make sure that we synchronize all this visualization and the artifacts that we're logging. We are synchronizing them correctly to into MLflow, and at the same time we are synchronizing it correctly into what's it called, MinIO. I lost the train of thought just for a second in there. Okay, yeah, that should be fine. we should be okay and good to go. So what's this complaining? It says unresolved attributes reference. Yeah, I think I'm using the wrong name. Visualizations. Okay. Now for the save artifact, just copy that. It's just like we are dumping it into the model. So where is it? Yeah, just before this, I'll just say dev save artifact. What we're doing essentially is just to do using job lib to dump all the what's it called, all the models. Yeah, we do self dot scalars, then we have into the temporary directory of tmp/scalars dot pickle, then job lib encoders, feature columns. That should be fine. I don't need the models for now, so I'm just gonna import job lib. Okay, now we need to save these models as well, so we just save that and we say import. Let me just comment that. So save individual models in the expected format. Then I have import os make directories and models. So for my SG boost, I'm going to have XG boosts in here. We do the same for light GBM. Yeah, and we do the same for ensemble. Once that is done, we can just do like I suppose we can do let me not make things complicated. So if XG boost is essentially I'm just trying to like make sure that the models are correctly trained and exported. So I'll just do job lib. Otherwise we have an error once that is done. Yeah, so I'm just gonna have SG boost model.pickle. We do the same for light GBM. Okay, then we do the same for ensemble. Cool. Yeah, and then let's log the attribute self.mlflow manager.log artifacts in temp directory. Everything is written to temp directory, so I just log everything in there into my artifacts, and I can say logger.info artifact saved successfully. Now let's go back to our implementation. Once we finish where is it? Yeah, this one. We said we are saving the artifact in here. We have the current run ID. I'm just going to import that. Import MLflow. Okay, and at this point we can just say self.mlflow manager.endRun. So the status is finished by the way, which is I think kind of the point. But yeah, once we end the run, we don't necessarily have to pass the status finish, but yeah, we're done with that. And I can have my synchronization in place, sync artifact to min.io s3. All right, that will be the last one that we need to do to ensure that everything works fine. I'm just gonna say from utils.mlflow s3 utils, I'm importing the MLflow s3 manager. So in my MLflow s3 utils, I'll just copy that into this and we can walk through the code base. So essentially what we're doing in here is for our MLflow s3 manager. So we're saying get the boto3 using the access key and secret key, and then the environment the region is that. We are uploading this to S3 using those keys that we've just done, the run ID. I suppose you can just put this directly. You don't necessarily have to do this. It's something that we can do, so we can remove this. So before now, I was using the first two characters, the next 4 characters, and then the run ID and all. But you don't necessarily have to do that. So you just construct the keys, and that should be fine. And then the upload is done in here. Then log artifact with S3, that should be fine. Synchronization is from MLflow into the directory, and the same thing, you don't necessarily need to do this. First two, you don't need that. That should be okay. Then list the artifact, you don't necessarily need this as well. Okay, and that should be okay. So if you start with the run ID, you can use the run ID to filter out that. So essentially we list the artifact implementation, the synchronization is here, the login is here, the upload is there, and that's all we need to do. So we're using Boto3 in this case. I was contemplating using S3FS before, and that was why in my requirements.txt you probably see S3FS, but I already have Boto3 in place, so there's really no point. But I was contemplating on that. You can use S3FS if you want as well, so it should be fairly straightforward. Okay, all right. Now logger.info, we are synchronizing artifacts to S3, and in here maybe not mean AOS3, just S3 should be fine in case you want to use S3 bucket for that. So S3 manager is going to be MLflow S3 manager. By default it's automatically sets that. If you can see in here, it automatically sets the client by default, so you don't necessarily need to pass any argument into that. S3 manager is that, and then why is this complaining? Yeah, of course, because you don't have any except rather. So we have S3 manager dot sync MLflow artifacts to S3 using the current ID. Then logger.info, artifact synced successfully to S3. All right, let's verify to make sure that everything is working fine. So I'm gonna have from utils again .s3 verification. S3 verification. You don't need this part, but just to be sure that everything works fine, I'm just gonna have verify S3 artifact, then log S3 verification results. Okay, now we don't have that in place, so I'm just going to copy paste that in here into my utils, and we work through it again. So we are verifying in here using the run ID. So what we do is just go into MLflow tracking, get the client run ID, get the artifacts URI, and then confirm in this case that they are all existing as expected. That's all we need to do. We are just expected artifact versus what is currently present. Then if there's any verification results that we need to do, we do that in here. All right, so that's why I have verify S3 artifact and log verification results in here. So I can just quickly call those two and be done with it. So I just say logger verifying S3 artifact. So we say verification result is verify S3 artifacts using the run ID. I'm just going to have run ID. It's going to be the current run ID. Then the expected artifacts. Yeah, expected artifacts is going to be we're expecting models, we're expecting scalars.pickle, we're expecting encoders.pickle, feature columns.pickle, then we're expecting visualizations, isn't it? Then we're expecting reports. Yeah, these are directories. Models is a directory as well. So these are what we're expecting to see, and whatever the final result is, we can just say log S3 verification result. So if there's no result returned, if not verification returned success, yeah, we can say the S3 verification failed. Otherwise, failed to synchronize into S3. All right, and that should be fine. Yeah, so it tries to log this. Let's see, we have a try catch in here, and I think we have an outer try catch as well, don't we? Yeah, we have an outer try catch, so I need to have two try catches in there. So again, just move this out, and I have except, and I'll just move this out. Is that right? This is complaining. It says, let's see, I'm just gonna collapse this. Yeah, the try is fine, the except is fine, and I think I'll just collapse that. Yeah, what's going on in here? We have a try in here. Well, apparently that wasn't closed. Was it? Yeah, it wasn't closed. So let me yeah, I think everything in here should be inside of this try block. Even this should be inside of that try block. Yeah, it should be inside of that try block. So and this should be in there as well, so I can move this in. Okay, I think that should fix it. Yeah, I don't know how I missed that try catch block, but yes, everything that we just did should be inside of that try block, and this should be inside of this try block as well. Yeah, that should be fine. And then we finish this our ML flow run. If everything fails at this end, we are not able to successfully end run, the status will be failed. Yeah, and I'll just what we do at the end of the day is to just return results. And yes, that's about it for our train models. I know it's a long run. Let's go to our what's it called, in our sales forecasting training for the code, so, and continue the implementation. So our model trainer essentially should be done by now. Just at the top here, I'm just gonna remove that. We just added the include function, so that should be below that. Okay, so now once we finish training the models, let's see, where are we? Yeah, train the model. So we have our model trainer. Okay, then we did the aggregation. We have the sales date, PD. Yeah, let me see, we just finished the trainer. Yeah, that's fine, and I'll just have my, yeah, that should be okay. Yeah, my source, so I can get the train df. I just wanted to get back into the context. All right, test df as well. Then I can have my dot prepare data, and the data that we are preparing will be the store daily sales. Yeah, the target column will be sales, the date column will be date, then the group column in this case will be the store ID, and the categorical column will be the store ID as well. Okay, and we don't need this use up to now. By default is true, so we're using that. So in our case, we just do logger.info. We have this as train shape, as train df, the validation shape, val shape, the test shape as well. So we can visualize those directly and see what we're working with. Okay, now then the results in this case will be the trainer or train all models. So it's not train models, it's train all models, isn't it? So I'm gonna have my train df, the validation df, the test df, and the target column will always be sales, and I'll be using use up tuner to be true. All right, now for each of these models that are returned, model name and the model results in results.items, I'll just log this implementation. Just quickly log that, and I'm going to say if there's metrics in the model result, just log each of the metrics and print this model comparison that we're doing in there. So our serialization in this case will be serializable results. Serializable results will be that, and then we just loop through for model name and the model results in result.items. I'm just going to have serializable results for the model name will be will be this. Let's just put it like this, metrics as model results, and let's get the get metrics, otherwise put an empty value in there. Cool. I suppose yeah, that's about it. I'll just say import MLflow. Don't we have MLflow? Let me see. MLflow, do we have it? We don't. I don't think we do. So I'll import MLflow, then the current run ID. Current run ID. It was in a separate library. We have mlflow.active_run.info.run ID. If mlflow active run, else no. Okay, cool. Yeah, but we just imported MLflow, so yeah, it's MLflow, not MLfile. All right, so just return the training results, the serializable results, and the MLflow run ID. Run ID will be that. Okay, cool, and that's it. Then the only thing is just to evaluate the best results. In this case, evaluate the model. So let's get a task in here to have evaluate models task with the training results. I suppose that should be fairly straightforward. So we have to import. We don't need to import in here. So I'll just say my results that is coming from the training result, and I'm going to bring in MLflow manager into the picture. It's going to be this, and the best model. The best model name is going to be none, of course. By default, the best RMSC is going to be float infinity, and the reason for infinity is we want to be sure that whatever you have in the infinity plus is always greater than the RMSC. So we just check which one is the minimum value between the RMSC and the infinity, which is always going to be the RMSC, of course. So I'm just going to have if metrics in the model results and RMSC in result metrics. Then the RMSC will be best RMSE. Yeah, I just extract that, and then the best model name will be the model name. Yeah, that's kind of straightforward. And I can have logger.info, the best model with the RMSC of that. Then the best run is going to be, of course, MLflow manager dot get best model, and the metric in this case will be RMSE. Why am I wrapping this? It's going to be RMSE, and the ascending order is going to be true. Yeah, so we just get the best run essentially. Just return that. We're going to have the best model. It's going to be the best model name, the best run ID, best run ID. It's going to be best run and get the ID from there. Cool. Yes, that's it. That's for the evaluation. Then we have 3 more tasks to implement. So the first task in this case will be the registering of the best model. So dev register best model task, and we have evaluation results. All right, and essentially we're gonna have evaluation results from there and get the best model from here. So the run ID is gonna be evaluation best run ID, evaluation. Then the MLflow manager is gonna be MLflow manager. Then the model versions is gonna be this, which is usually by default. As we go along, the same model, if it is the same name, you have version 1, version 2, and the rest like that. So for model name in XGBoost, like GBM, we don't need cat boost. That will be a separate. Why is cat boost not leaving? Version, it's going to be MLflow manager dot register model with the run ID, with the model name, and the next one will be the same thing as model name, isn't it? Model name. Let's see what you have in the register model. Just want to be sure. Register model. So if you check our MLflow utils, we should see register model. We don't have the implementation. I suppose something is missing in here. Our implementation is incomplete, so I'm just going to copy paste the rest of the implementation. So we have so we did the initialization the other time. We didn't finish this. We have the start run to start the run, the log parameters, and then the logging of the metrics, logging of the model, then logging of the active file, the figure, the end run, the best model, loading of the model. Just show you what each of these implementation entails. So we have so we have the init, the start run, the log metrics, log params, log artifacts, log figure, end run, get the best model, then loading of the model. Now this was what I was talking about. So register of the register model is where we are doing the registration, and we are transitioning it to production in this case. Get the latest model versions. That's all we need to do in there. Thanks for spotting this. I almost missed this part. Okay, now when we register the model, let's see, register best model. Okay, we have the version, then we can say model versions. For the best name is going to be the version, and then print logger.info. I mean, it's kind of init at this point to be typing print registered model name with the version. All right, and I can return the model versions. Okay, then transition to production. Let's task again, dev transition to transition to production task. We have the model versions in this case at this point, so I can just have my MLflow manager, the model name and the versions, and then transition the model to production, and then I can say that's fine, and I can just return models transition to production. Cool. Then the final one in this to generate the performance report. So I'm just going to have a task in here, and I can say generate performance performance report task, and that will be the training results, validation summary in this case. All right. Again, let's go through the implementation. I suppose this is gonna be different. Yeah, that is nothing. Yeah, I'm gonna have results. It's gonna be training results, and get the training result from there. Training results. Okay, that's my training results. So the reports that I'm gonna be generating is gonna be timestamp is the ISO format, then data summary is gonna be the total rows. This is like icing on top of a cake, so if you don't want this, it's totally fine. Validation summary dot get total rows is validation summary, else 0. Yeah, that's fine. I have files files validated will be the validation summary, get that. Then issues found would be get the issues found, otherwise empty, I suppose. Yeah, then the issues is gonna be validation summary, get the issues. And finally the model performance, performance is gonna be the, I suppose I'll just put this as empty for now, because I don't think, yeah, that's fine. That's fine. Okay, yeah, so that would be my reports. So I suppose this should be equal to, isn't it, reports. Cool. All right, that's fine for my reports. The only thing that I want to do is get my results in here. If result, wait, so that's my report, isn't it? I'm just gonna have if results, then for the model name and the model result, in the result I'll get the metrics, and then report of data summary, isn't it, report, then data summary is what I'm expecting. Then where is it? So I have model performance. I suppose it's not supposed to be inside of this block, it should be outside, isn't it? Yeah, model performance should be separate from data summary, so I suppose this is wrong. So model performance for the model name is going to be model results for the metrics. Okay, that's fine. Import JSON, and then with open the performance report. In this case, just do logger.info performance report generated, and I can return the report. That's all. Yeah, I know it's a long walk down this hill, but yeah, we're done with it. Just one final thing is to link up the task dependencies correctly. So I have the training results. Let's confirm this. We have the train model validation summary, then evaluation report. I don't know why is that using evaluation. Evaluation report. I have my training results in here. The model versions is fine. Then I'm transitioning this to the production. Then the reports that I'm generating, report is going to be this, using the training result and validation summary. And one final task that we just have to do is just clean up. Yeah, once we are done clean up, it's going to be a bash operator. In this case, I'm going to have the task ID to be clean up. I'll just call it task ID of cleanup. Okay, why do you always want me to use temp? I don't want to use that. And the bash command is going to be as simple as remove rf and anything that you have in temp sales data, and then temp performance report.json, and simple true. Right, cool. That's all we need to do. At the end of the day, reports can just point to cleanup. All right, now let's get our bash operator into the picture. We have from airflow.operators.bash import bash operator. Cool. All right, yes, that's all we need to do. And I can just take this for a spin and ensure that everything is working just fine. Okay, let's just sort this correctly. The import should be fine, and I think I don't know what I did in here, so the owner should be code review. Yeah, that's fine. Email on failure. Why is this bug? Yeah, that should be okay. Yeah, that's fine. That's fine. For now, I just want to generate up until 2021 12/31, isn't it? That's the first year, and we can test with that. Okay, so let's check this out on the UI. If I just go back in here, it says there's an error. It says it could not open DLL type. Yeah, so what I'm going to do is I'm going to stop all these. I'm going to stop the Astro and kill all of them. In this case, I say Astro dev kill. So I'm just going to stop all the containers that are running. Then I can start everything from scratch again. Okay, let's go back to our terminal and then do Astro dev start. Before that, let me see if there's any pending image. Yeah, I'll just delete all of them and start again. I suppose you don't have to do that. There should be a flag in Astro dev that we can use to just build all the images regardless, maybe with no cache or something. I suppose if you check Astro dev and then check help, you probably would see something like that. So we have we have the start. Let me see, dev start help. Yeah, so it says we can have a flag in here to say no cache. Yeah, so this probably would be useful in this case. Yeah, and if you want to add build secrets like those envs that I was talking about, you can do that, and the env can be used in here as well. Yeah, I suppose that would work just fine. But yeah, let's start it up again and see what that look like. Of course, as usual, once we remove the images, we need to change this override. We rename the override first, and then we start up the services, then start it up again once it starts. And the reason is just for us to be able to build the network in this case. So we get the base network that we're using. So in your case, if the name of the project is not Astro Sales Forecasting Pipeline, you probably need to change this name. So if you change it to something like Sales Forecasting Pipeline, for example, this will change to something different. So you have to be sure that whatever name you've got in this network is the same name that you're using in your network here to extend the services, the base services. All right, so I'll just rename this again, and the project should be up by now. And if you check the containers, you see that it's up, and we're gonna see a launch once it's done. Cool, so that's fine, and I'm just gonna do dev start again, so you can rebuild the image with the override and import all our dependencies, dependency containers that we just added to it. Well, additional containers, that would be the right word. Okay, so the project has started, and yeah, all of them seems to be okay. So I'm just going to close this up and see if I can refresh this, and the error should be away with you. So he said generates generates log and visualization. Is complaining of the any. So generate log and visualization, where are you? So here we have, what's going on in there? Okay, generate log and visualization. Yeah, so I don't necessarily need to add this. I'm just gonna close that. Okay, and do a refresh in here. So let's see if that error goes away. Yeah, I think I just need to repass the DAG. Yeah, that's fine. Just refresh this and that's fine. And in my sales forecasting training, I just turn it on and refresh this, and everything seems to be starting up. I mean, it's just that what's it called, the data type that I just had to remove from there. Okay, so extract data task, that seems to be running and it's generating all the data sales. Yeah, that should be stopping now. Yeah, so it stopped at 31st of December 2021, and this is 217 days, I suppose. So yeah, let's check the validation. So the validation seems to be working just fine. Validation passed, but the train model doesn't. Okay, so he said, let me just wrap this up, and said, he said columns, it says task failed with this, key error is MLflow, and what's the error message in particular. So yeah, we have train models in line 35. So in my train models, line 35, and MLflow init in line 26. So let's check those two out. In my MLflow, where is it? MLflow utils, isn't it? Line 26. Okay, so it says he could not find the config MLflow. So in my MLflow, let's see what the config look like. Do I have MLflow? So what's this trying to say? MLflow config. So I have, okay, let me see my MLflow config. See, so I didn't add this config in here. So I have MLflow, and I just need to add the tracking URI. The tracking URI will be this. Yeah, tracking URI will be this, experiment name to be that, and then registry name to be this. Okay, I think that should fix whatever issues that I have. I don't know, this is an oversight, but yeah, that should fix it. I'm just gonna retry that. So this is up for retry, but I'm just gonna cancel it. Just cancel this as failed. I suppose, let me see if it is if I changed anything in the sales forecasting training. So this is supposed to be weekly, and yeah, it should be 1 minute, isn't it? Retries is 1, so even if something fails and I fix it before 1 minute, you should try again. So I'm just gonna go back to the sales forecasting, repass the DAG, and try again. Okay, so the validation is in progress. Okay, that's done. Let's train the models. So it failed before, but let's see what that looked like this time around. Okay, so yeah, don't mind this error. This is not a problem. It's just like a way MLflow tracking logs this, so it's not really an error. And you can see that it has a new study that is being created, and while this is in progress, you can check that out and follow the processing pipeline in MLflow. So if you check MLflow in here and go to localhost 5001, I'll just copy that and open a new tab. Oh no, it's localhost 5001. So in here you see sales forecasting, and this is in progress. You see the parameters that are being used, number of features, the validation size, the test size, and all that. So that is in progress, so we just wait for this to be done. Yeah, keep going. Oh, where are you? I'm just going to go to this UI Airflow, and this seems to be in progress. And you can see, just try to wrap this up. Wait, let's go back one step forward. No, yeah, my mouse, my navigation is all around the place. So I'll just minimize this. Oh, by the way, while this is running, before we go into that, you can see the charts in here, and you can see that after extraction, the validation goes, the running of the models goes, and then we generate the performance reports and the rest. Yeah, makes sense? That seems to be kind of straightforward. Yeah, let's take a look at this. You can see the byte samples tree keep changing each run, and you can see the best trial and stuff like that. The best trial so far was trial 25, but before the 25 you probably would see something like this. So it's just keeping track of, you see the best trial 6. Again, when it gets to 25, you see it saw a better result and it changed to that. Let's see if there's any other one. Yeah, it looks like best trial was 25 at that point, and you can see the feature importance that I was talking about. So in this case, the feature importance is 54%, quantity sold, the profit, the sales rolling mean, and these are the importance for each of those features that were taken care of in XGBoost. I suppose that will be the same thing that will be done for Light GBM as well. It should be done by now. Let's see what we have. Yeah, you see that we have profit of maximum importance, quantity sold is 67, then we have the rest of these features. Let's just compare. So these are just like the TQDM login and progress so far, and at this point it's trying to sync these to S3 MLflow. Sorry, MinIO, not MLflow. So you can check this out in MinIO 9001, and the username and password is MinIO admin. And if you go in here, you acknowledge this, you see that your run ID will be there, which is 127 blah blah blah, which is exactly the same thing that you have in here, 127 blah blah blah. Okay, and you can see in the metrics, the mean average error in this case is 7.6. The map is 14.5, 14.6. Ensemble, wow, that's 96% accuracy, which is good. Light GBM is 92%. Then XGBoost is 97%. Oh, that was close. Yeah, that was really nice. Good results so far. Let's check the visualizations. So if you check the predictions comparison, you see it in here, but let's start with the error distribution. So the error distribution across the board, it looks like Light GBM had the at first it had the error distribution very high, then it keeps going down. At 200 you probably don't see much errors at this point. Ensemble and XGBoost are not coming through. Then the feature importance, you see that the highest importance is this, which is the 54%. The profit is 24%, and you can see the 0.54 in this case. You get the point. I suppose if you add everything up in this case, you should have 100%. Then the Light GBM, you see 29, 67, and that's fine. You check the model comparison, you see the RMSE lower is better. So in this case, XGBoost had the best RMSE. The mean average error, you see the XGBoost consistently have the lowest mean average error. For map percentage, which is the mean average percentage error, you have the 11.7%, and the XGBoost performed best at 98%. Even though Ensemble at this point is more like the average of these two is 96, but you see that XGBoost had the 98% and LightGBM have 92%, which is good. I mean, let's compare the results. Okay, we just did that. You can see the prediction as close to actual as possible. Which one did we say had the best results so far? If you check this, we had the XGBoost as our final result. So let's check the predictions comparison. So XGBoost is the yellow, well, orange, not yellow. You can see that it's consistently close to actual. Yeah, not bad at all. Yeah. Then the residual analysis, this is like a box plot. You can see the distribution across that for XGBoost majorly. Then the residuals over time is here, and the QQ plot is there. Now all of this seems to be correctly logged in sales forecasting and MLflow, and you can see them as well in your, including the sales data. You can see them in the model. You can see the visualization as well in here. If you preview it, you should be able to see it, which is good. So that means everything is working as expected. The only thing that is left right now is our Streamlit UI. So what I'm going to do is just copy that into the picture and update our Docker Compose so we can have our Streamlit properly implemented. So just in the root directory, I'm just going to paste that in the entire code. In our, not in the DAGs, I'm just going to move that to the root directory. Okay, in our root directory. Yeah, in our UI, you see that we have a Docker file. So in this Docker file, we are installing all the dependencies, copying the requirement.txt, and installing all of them. Copy all of them, get the Streamlit server, the tracking, and the ports. So we have the health check in place, the Streamlit that is going to be running, which I'm going to show you shortly. That's it. So that will be our Docker file, but we're not necessarily using this. We're using this Docker Streamlit, but that wasn't properly formatted, so that's why it's a little bit different. So in our entry point.sh, we have all this installation, and we are running inference.py, server address 85.01. That's fine. I have a readme if you want to look into it as well, but let's take a look at the Inference app. So what we're doing essentially is to create a model loader in this case for our session state. Wait, we should have a yeah. So we start with the page configuration, which is the page title, sales forecast Inference. I'm just probably going to change this to Astro sales forecast Inference, and the page icon will be this. The layout is going to be white, of course, and then the model loader is there. The title is that. Let's have this as Astro sales forecast pipeline. We have a sidebar in this case, so we need to load the model, and I'll show you how to do that shortly. Otherwise the model will be here. So okay, so we have a button to reload the model. I mean, I just added this as an ad coding. This is not a good practice. I'm just going to remove this. We should always have a model run ID to go through, especially when we are comparing or loading this model in production. Okay, so now going back in here, I have my run ID. Yeah, I just load the model. So essentially the UI will give me a way to load the model. So once I click a button, the model will load. Otherwise it tells me failed to load model. And let me show you what that look like. So in here, if I go to the code base and I go to my, yeah, I need to restart my code. So let's do that. So in my Docker Compose override, yeah, in my override, I just need to yeah, I'll just copy the Streamlit configuration. So I'll just I'll copy that from my notes and I'll paste it in here. So if you look at what I have in here for my Streamlit UI, I'm using Python 3.11 Slim. Yeah, I'm an advocate for 3.10, but yeah, you get the point. The working directory is app, and I just run the bash commands. So once I run the bash commands, I do the installation, change this to like executable, and I run it. The rest is just like environment variable, including this in the app, and then linking that to that. So I'll just do Astro dev start, and our Streamlit UI should be bind. So let's go back to the Streamlit UI that we're talking about. So I just select the best model, which is going to be either of these three: Ensemble, XGBoost, and Light GBM. So the number of days that we can slide is a slider, so it's going to be between 30 days. So it's going to be the maximum of 90 days, a minimum of one value. And then once that is done, for the main content, I have 3 tabs: upload data, manual entry, and sample data. So at this time, I'll be commenting these 2 out, but you can leave them as they are if you want. Well, I'll just be using the upload data for now. All right, so in my tab 1, which is the upload data, yeah, I'll just I'll leave this as tab 1, and for tab 2 and 3, I'll just comment these 2 out. Yeah, just one sec, I'll just comment them out. Yeah, so that's my 3 tabs. So I have tab 1, which is, should be okay, and yeah, upload the file, and that should be fine. Yeah, so essentially when I'm uploading a file, a CSV, I have a file uploader in here. Once the file is uploaded, it loads the record, and it just preview the data, and I'll show you what that look like just in a sec. My Streamlit UI should be there now, and I should be able to see what that look like. So it's installing the dependencies. But that will be registered at localhost at what's it called, 8501, isn't it? 8501. Yeah, that's where it's going to be registered into. So you just check this out, and yeah, it's ready now, and I can refresh this page, and you probably would see something similar to this. So this is what I was talking about. On the sidebar, I have a load model. So if I click on this is going to try to connect to our ML flow and load the model. So you have 3 models right now. Yeah, I just commented that out. It says tuple does not exist. So what I'm going to do is go back into this and just undo my removal, the code removal that I did. I suppose we don't have to go through the details of those. I'm just going to refresh that. That should fix the issue. Okay, so I'll just log this up again, load this again, and I have 3 models. You can see that it's working fine just now. I wasn't ready to do any debugging on that front. So now I have my Astro sales forecast inference, and for my upload data, I need to have upload in there, and you can also create a sample data in here to look like this. So this is what your sample data will look like. Well, yeah, if you look at the manual entry as well, you can create the manual entry for each days and each store, and you can use the manual data for that. But what I'm going to do is upload a sample data. In my case, I already prepared a sample, and I just pulled that up from my notes, which is going to be somewhere here, and I'll just upload that. That will be part of the, in fact, I just put it in the code base, just below this in the root directory. Yeah, in my root directory, I'll just copy the sample sales data. So for 2024, I have for 90 days, this is what the data will look like. Open the table, and you see from October to November, that's 60 days, I have this data in place. So that's what I'm going to be using for our experiment. So I'm just gonna go back in here in my sales CSV, open in Finder, and I'll just upload that in my Astro sales forecasting pipeline. I'm just gonna copy that and go to the browser and drop it in here. Okay, so it has 61 records and you can preview it. So this is what the head look like, literally the same thing that we had before, and then generate prediction. So I just run the prediction and you can see so as at December 1st, you probably will see the confidence level. It's expecting, using ensemble model, it's expecting that the total sales forecast will be 68,000, and on a daily average it's going to be 2,291. And if you change the model from ensemble to XGBoost, which was having the highest precision in this case, if I check again, you see that I have 2,951. Don't forget there's a difference in this case. Now 2,951 is the daily average, but with XGBoost, but with ensemble 2,951 against 2,919. Yeah, so that's why it is probably best to, and you can see the average in this case. So this is performing poorly. On average is saying 1,005. Meanwhile, ensemble is saying 2,288 for a prediction, and it's probably going to be a little bit different each time you run this. Well, you're going to have the maximum upper bound and the lower bound as you go along, so it should be fairly straightforward, and you should be okay in this case. So yeah, taking a look at our architecture again. Taking a look at our architecture, it looks like we've sorted this out. And if you want to extend these functionalities to include the Flask or Streamlit or Spring, we'll just do the Streamlit. So if you want to use Java or Python, you should be fine, and it should be fairly straightforward. And again, for the optimization that we talked about, that we're going to look at, we have the optimization for the hyperparameter tuning. We have a tree base and faster training in this case, and individual model will be weighted using ensemble strategy for the ensemble prediction. Then the same thing, the raw data, we have the time series features. These are all for the Prophet and the Prophet model. You have the feature data set in there. And then for this, again, for the architecture, you have the data sources, the orchestration layer is Astronomer, and then the ML pipeline is literally the same thing we've just done so far: XGBoost, ensemble model, and light GBM. You register the model, and in the ML platform, which is MLflow, you can export that into a visualization, which is Streamlit, and in the Inference system, you can see it in here. So these are the visualization or chart and analysis that are extracted from here. I suppose I need to just reduce this image a little bit. Let me just move this to the side, and you can see my bad. Did this cover anything? Yeah, this is the only one that got covered. So I have the data sources in here. I'm linking that to the Astronomer, which is fine. The ML pipeline seems to be okay, and you can see the MLflow in here to be fine as well. The visualization and analysis is here, and the inference system is here. So we can see all the three in the Streamlit UI. The client operations, start, run, tracking server, and that's all. And in the UI, when we are loading on Streamlit, we have something like this. We have the UI connecting to the model management, the prediction engine, and the charts that are generated. And essentially, you can also export this data to CSV, and that should be fine. Yeah, it should be fairly straightforward. Yeah, I'm just gonna save that, and this is the latest one. And if I open that up, yeah, you see the result in here, and the predicted sales is going to be here. The lower bound, the upper bound is here. So that's really good. I suppose everything seems to be working just fine, and we've satisfied all the architectures that we talked about in the initial starting phase of this video. Yeah, so yeah, we were going to be churning out a couple of contents on this machine learning and how it works and all that. But you can take a look if you want to get started. The next thing will be to deploy this to the cloud. So what you need to do is the account that you created before. If you go to the Astronomer CLI, you'll see that you have a way to deploy this. So if I go to, if you go in here and search for deploy, so if you deploy with Astro in here, so if you want to deploy, you can easily deploy. So you need to I suppose you need to go through the documentation in here, but I have one straightforward deployment. Astro deploy. So if I want to deploy this, so the only thing you need to do is run this in the time. You first need to, of course, create a deployment. If you create a deployment, so you need to create a deployment first on Astro Cloud. Once you create a deployment, you can now deploy based on that using the deployment options. You can pass in the deployment ID and all the other flags in this case, but a sample is that you can have once you have your deployment ID, you can get Astro deploy, and then it's going to save this up. If you want to save this for future deployments, you can do that, but essentially just go through this documentation. It's kind of straightforward, but let me know in the comment section if you want us to deploy this end to end into the Astro Cloud. Thank you very much for watching. If you have any questions whatsoever, drop them in the chat, in the comments below, and I'll try as much as possible to respond to them as much as I can. So thank you very much for watching, and I'll see you in the next one. Cheers.